Yeah, a very warm welcome to our esteemed juror, Mr. BP Singh, and our authors to the technical presentation, paper presentation for the year 2025. As we begin, I would like to give a brief intro of our jury member, Mr. BP Singh. Mr. Singh is a former member of the Delhi Electricity Regulatory Commission, and he brings over 40 years of experience in the power and energy sector. To begin with, we are first covering the disruptive innovations for utilities theme, and we have a total of 9 authors in this theme. We'll begin with Mr. Vikas Gupta. He's a DGM Noida Power Company Limited. Welcome, Mr. Gupta. And I would just like to inform that we have to, abide by the time restriction. We have 15 minutes for presentation and 5 minutes for our chair's remark. Request everyone, all the authors, to kindly abide by the time restriction. Thank you. Thank you very much. We have uploaded your presentation here.
Hello. Good morning, ladies and gentlemen. While we are starting with our first presentation, my brief to the speakers is please don't waste your time on introducing your organization. You can only share your website. People can find what your organization. Come down to the key topic. What was the problem statement and why you did this? So I think to cut short the time, will be a better option. Thank you.
So, good morning everyone, and good morning jury sir. So today, without wasting my time and without wasting your time, I am starting with my presentation on the topic object-based classification for vegetation encroachment analysis and change detection in Greater Noida for electrical network planning and utility management. So, as you see that Greater Noida is our, we have covering the 335 square kilometer area of our license area, and this area is rapidly emerging. So the study of this is very necessary because there is a lot of infrastructure growth as well as electrical growth is there. So for identifying this reason, we have gone for our project explores the potential of object-based classification algorithms for land use changes over the period of time for vegetation encroachment and land-based change detection over the period of time. So let me So what is the context? Because Greater Noida is a rapidly emerging area, so a lot of construction happens during the time, and there is a change of land use, land class also there. So we need to plan for electrical infrastructure. And also there is a overgrowth of vegetation over the period of time on the overhead conductors, so that it will have disruptions for power failure or breakdown. So that study requires. So what is the impact of that study? Because of taking the GIS as a base technology, we have developed the change detection mechanism through the satellite imagery for the 2 period of time, and then we can analysis on the basis of signatures of satellite imagery and provide the capex planning as well as electrical network growth of that particular region. Second thing, the vegetation encroachment. So for that we have captured drone imagery, and for the 360-degree point cloud from the software, we can set the offset of that particular imagery and get that pruning to be automated through the divisions. So what is the, now I am going for the presentation of this particular land use, land change detection. So for that, we have taken the 3 period of satellite imagery. So satellite imagery is of World View 3 of 0.3 meter resolution. So we have 2015, 2019, and Google Earth imagery for the recent one. So we have collected the signatures of water bodies, agriculture plot, vegetation built up, and barren land. And for each signature, we have collected the 80 classes, 80 samples, which we fed into the our algorithm that have been developed, and then we can make the analysis. So the analysis is based on the supervised classification technique. So supervised classification technique in which we have fed the signatures, and then over the period of time we have seen there is changes in the agriculture land. So if you see in the agriculture land, it is 8% decrease from 2015 to 2019. Then vegetation, it is decreased around 8%. And built up will is increased around 22%. So this study also, we have prepared the thematic map on the basis of that. If you are seeing the 3 imagery, then you have seen the difference also, what all changes are there. So for the vegetation encroachment over, so we have put one region in Greater Noida called Tusiana, and for that we have created around 280 drone imagery, captured the drone imagery. We have itself our drones. So we have captured that imagery and put it in the 360-degree point cloud. We have generated that point cloud on the imagery and created the offset for the around 10 meter, that which vegetation is obstructing the power lines and needed the pruning. So particularly the feeders which are tripping, our aim is to provide the uninterrupted power supply to the consumers. So basically we need that pruning so that we can provide the division data to the divisions, operations divisions, so that they can initiate the pruning and lessen down the breakdowns and power failures, and even in some cases equipment failures are there. So the findings of the use case study, that change detection, for the change detection period, we have 2 substations, Hateva and Girdarpur, which are overloaded. So we have identified the new substation location based on this analysis, so that these 2 substations would not get vulnerable, and we will provide the continuous power supply to the new consumers. Second, for the identification of power line encroached vegetation, we have done for the 360-degree point cloud, we have initiated the tripped feeders which have more breakdowns. So we have make 10 meter offset of that particular regions and marked by the lat long, and provided those things to our division team for pruning, initiated the pruning. So key takeaways from this project is, this project, since it is a change detection project and we have an emerging area, so we can provide the more capex planning to the consumers, to our stakeholders, accurate capex planning, that how much substation would get introduced in the later years, and also electrical, for the electrical network augmentation and network laying, we can initiate that how much, or substation locations, so we can find out the consumer substation locations also. So suggestion is to that we have to do that study for 2 years, for the period of 2 years, for every 2 years, so that we can find out the changes on that. So this is, so we have generated also the point cloud from the vegetation also, and definitely we are going for more imageries to, we have next course of action is more tripping feeders in which trippings is there, and we are going for more imagery collection and creating the point cloud and initiating the repairment of that. Thank you.
Thanks, Vikas.
So,
really, it's a good development that at least you are able to know where the particular plantation is going to infringe with your overhead transmission distribution network lines. And you can take a timely action for pruning. My one question remains that when over a period of time, now we are even changing to underground distribution network on the cabling. Will it be ever used for safeguarding your right of way? That people don't put a tree on top of it and then you are not able to actually maintain your cables or get a repair of the cables. So is that also in a plan? That you start knowing that yes, some vegetation growth has started and remove it right at the day one rather than waiting for it to become a tree?
definitely, sir, it is a very good question, and basically vegetation growth, if you are in the botanical terms, you can see you have to analyze the flora and fauna, and if the growth is more in that particular area, then definitely we will go for the underground cabling system also. So we can plan on the basis of analysis that where we need more pruning or more periodic pruning, we can go for the underground cabling system.
Not only where you need more pruning or whatever. Question is that once the cable is laid, whether the right of way, on the right of way itself, a tree is planted. So encroachment doesn't mean that it's a natural growth. Somebody else has planted there. Then its roots will hit your cables. And if the cable gets damaged, you will have to again find out what is the alternate route of repairing the cable. Because cutting a tree will become a major headache than pruning, because that will not involve pruning at that stage. So whether you will be liking to protect your right of way, but at least in the long run, especially when the environmental norms are becoming stringent and stringent, it
Noted, sir.
become a major problem in the times to come.
Noted, sir.
Because from the regulatory side, we always
Yes, sir.
look at what could be the other
Even,
problems which you might face.
Even for the pruning side, we have to also adhere the forest department guidelines.
Yeah.
So
Dismantling a tree will be a much bigger issue.
no, basically this project, in this project, the more bushes which are coming from the tree get pruned. Not the complete tree has been removed.
Unless you plan a underground cabling corridor with a concrete top, that nothing can be grown on top of it.
Yes, sir. It is a vital capex investment, and we are certainly going for in the coming years for capex planning. In the capex planning part, we are going to take care of, and definitely it is a very good suggestion from, and I am keeping note of that, and definitely
let me keep the house open to questions and answers. Anyone having questions, please. You can identify yourself and ask the question. Please.
Gupta, I retired as economic advisor from Accenture Electricity Authority. So I have some understanding of the electrical trade, not much. 2 points I want to make. One is that you did not mention about the environmental impact assessment. Because the way sir is talking about it, you will probably have to make it a repeated process. Because the trees, they grow all the time. And second point is that you did not mention about uprooting the people.
uprooting the
people. You see, झुग्गी झोपड़ी हमारे यहाँ बहुत common है. चाय का ढाबा भी होगा, पान की दुकान. All these things, they are part of our culture. And no matter what you do, they just grow. I mean, you look at the Yamuna bank. You know, आप अंदर चले जाएंगे, you see the kind of people who are growing, vegetables, and they are selling also. Sometimes they sell the vegetables and come to the main road. So these things are very difficult to uproot. So I was just thinking that where do you factor in the people dimension? I'm not sure You have taken into account the bushes and the greenery and all. But there are going to be a lot of people also on the way. And how are we going to provide them livelihood? There is another issue, which is beyond the environmental impact assessment. I don't think they look into this. They only look into, the green part of it. But the people-centric approach also is needed.
Yeah.
So perhaps you should factor it somewhere in your thinking.
Basically, for the people-centric approach, we have also, I have not mentioned in my PPTs, the encroachment which have been illegal since our NPCL is the merger of Greater Noida Authority, and so we have the encroachment in the particular region. So we will notify our Greater Noida Authority for that, so that they can take care of, because means in the power line, if they have encroachment, so certainly there is a chance of fatal accidents and more. So yeah. So we will notify our Greater Noida Authority, because they are the one who can remove those encroachments, illegal encroachments, and we are not supposed to take care of.
I think what you need to do is a more frequent drone surveys.
Definitely.
To stop encroachments right from the day one. Because once you have laid the transmission system or distribution network, that time there was no encroachment, the right of way was clear. So if you know that what is coming up, then you can stop it right at that stage. I have also seen a case, I think about 9 years or 10 years back, there was a major power failure in Delhi when a lot of the towers fell down. And when the whole thing was being inspected, even one Jhuggi Jhompadi was found built in the tower itself. On the upper elevation where there are cross members are there. People were staying there on that floor with a ladder put on that. So it was never known to anyone. Only when that towers fell, then the people started going from tower to tower and finding that this is there. So finally more detailed and I think more frequent surveys are required to find out that nothing happens, which becomes unmanageable if we keep a longer interval.
Sir, for that, I am elaborating that we are the first in the utilities which have started the drone survey in 2017. So lot of DGCA stringent guidelines are there. So now they have some relaxations. So we have purchased micro drones of less than 2 kg, and we have UIN number generated on the name of the company. So there are very few utilities which have their own drone and they are flying for their own purpose. So definitely for the more drone surveys, we can noting your this is the vital thing, and definitely resource and everything is also there, which is taken care of.
Okay,
any questions?
Vikas, thanks a lot for the nice presentation.
Thank you, sir. Thank you. Thank you all.
Next speaker is Sumangal Bhaumik.
Yes, Mr. Sumangal Bhaumik from Abacus Institute of Engineering and Management.
Welcome, Mr. Bhaumik.
Good morning, everyone. I am Sumangal Bhaumik from Kolkata, West Bengal. Today I discuss a topic SVM and DWT based detection and classification of microgrid fault using single point measurement. So nowadays the use of renewable energy increase very rapidly. So the thing of the integration and penetration of renewable energy in conventional grid or microgrid is started growing very rapid, very challenging, and due to some government scheme, it is very important, very easily and the people are want to integrate renewable energy and sell, then they are very motivated due to some government schemes. The thing is that this, in case of microgrid, the thing is that it is very challenging in point of reliability. What is this? Because the term of prosumer, because in case of distribution end, lot of consumer now generate solar and they can sell in grid by smart meter and other things. So the thing, the concept of prosumer and the bidirectional power flow in microgrid is very challenging in point of view of reliability, because the fault of microgrid is very challenging to detection due to and a conventional system like overcurrent relay and other things, it is very difficult to detect the microgrid fault. What is the challenges, main challenges? Because what is the main challenges with three terms. One is bidirectional power flow. In case of microgrid, we see that power flow is bidirectional. Another thing is the low magnitude of the fault current. In conventional system, the fault current compared to the fault current level is very low in case of microgrid. Because in conventional system, if the fault will be occur, then the alternator and other generating system provide the fault current. But in case of microgrid, basically it is inverter based system are connected in the grid. So if the fault will be occur, the fault current will be very minimum. So it is very important to detect the fault using conventional method. So various research work going throughout the world, a lot of researcher work on this topic, how we detect the fault, how we classify the fault to improve the stability and the power microgrid. So some existing method or some important method nowadays, that is some statistical signal processing approach to detect a fault. Another is wave-based neural network method. Some S-transform method will be used to detection the fault. Empirical mode of detection and Hilbert transform method also used. And support vector machine, that is SVM technique, also used to detect the fault. So what is our method or what is our salient feature? We can say here we consider a radial network. In case of radial network, it is very difficult to identify the fault because the voltage level is distribution end. The voltage level is low and current also, the prosumer, number of prosumer is more. The thing is that the single point, here we introduce a scheme where we detect the fault using single point detection from PCC, that is, and here we use DWT based analysis, that is discrete wavelet transform, and then if the fault will be detected, then we can also classify the fault, that is which type of fault and where the fault happens. So this is our main objective. So here we discussed our scheme. Here we consider a 9-bus system of radial system where bus 2 and bus 5 are connected with some PV module. That is the bus 2 and bus 5 acts as a prosumer, and other are all the and it is grid connected mode, grid also connected. The thing is that what is our scheme? So the current measurement, we only measure one thing, one parameter, only current. So we measure the current at PCC and every phase, that is phase 1, phase 2, phase 3. After collecting the current data, we apply DWT, and basically here we use kurtosis analysis. And because we already say the magnitude of fault current is very minimum, so it is very difficult to understand the fault. So we apply the kurtosis analysis, DWT analysis, and we get the kurtosis data, and we create a thumb rule and compare the data with respect to normal healthy condition. And thing is that if the value of kurtosis is more than reference value, definitely it has some range, then we consider it is fault. So DWT is very fast, and fault or no fault, this thing is we clearly understand very fast. If fault will be decided, then the system will be islanded or anything, islanded the system. The thing is that now the second challenge is, that is classification the fault and where the fault is happens. For this reason, here we use some machine learning technique, that is SVM. Using SVM, we use, we detect the type of fault and where the fault is happens. So this is the normal current at PCC, and this is the fault current after bus 6 LG fault. Now thing is that the DWT result, if we see the result on every bus, and here we can easily classify the which fault and where the fault is happens. This is the DWT result, and line S means symmetrical fault in line, bus 9 LG means LG fault at bus 9, and others. So here you use the this technique, and so the two things is that first detection the fault, if fault happens or not, and then classify the fault and where the fault is happens in bus or line and where. This is a case study. Another thing result. This is the confusion matrix of SVM, where we get already 100% accuracy to detect, classify the fault, where the fault is happens and which type of fault. And in our paper, we already mentioned a detailed analysis of this part, because here in our paper we use almost 15 types of method of machine learning to classify the fault. Here we just as a sample I put in 3, that is SVM KNN tree. But here we get the maximum efficiency, that is 100% accuracy at SVM cubic method. And what is the salient other importance of this study? Already this type of study, lot of researcher works in this topic, this type of study. The reference will be given in our paper. So there is basically 2 points. One is execution time and another is accuracy. Because fault and classification of fault, detection of fault is very tough. So execution time is very important. So thing is that we already put a comparative study. There are a lot of researcher work, and their execution time is good or more than our method. And if we in respect all our thing, execution time and accuracy is good with compared to other method. So basically, here we challenge detection, the classification of fault in renewable energy penetrated microgrid system in our radial 9 bus system. The fault classification with the only current signal, we already said. Here we need only one signal, is current signal. And the table also show, and we already got the 100% accuracy. So this is the thing. Thank you.
Thanks, Mr. Bhaumik. One quick remark. You are saying that it's for microgrids.
Yes, sir.
But renewable generation is spread all across entire grid. So can this exercise be extended to those? If yes, how? And especially when you are going to even have V to G, where you do not even know which point this flow will take place. How do we handle that kind of situation?
Sir, actually, it is a very good question. We already discussed in the studies microgrid, it is grid connected mode, but mainly when grid is not happened, then only the current will be, the magnitude of the current is very low. If the grid connected mode, then current will be, the fault current will be provided from grid. So conventional system is more than sufficient. But thing is that when you consider the microgrid, because the electric charging, electric vehicle are everywhere. In West Bengal, that is a village that is called Sundarban. There is no, still now there is, that now it's working, is not conventional grid. That the total electricity is provided by wind, some biomass and solar. The thing is that if the islanded mode grid connection, in that case, our study is suitable. And another important drawback of us, we study on radial system. But in case of actual, if you think of broad case, there is not radial system in broad case. So that is our one disadvantage of this study. So you say that the thing is that in case of broad cases, still we not implement this algorithm in broad cases. But here our next target is we use transfer learning technique, because if it is suitable for, if we get the data from 9-bus system, is it applicable for 10-bus or 8-bus system or not? But main challenge is in case of broad network and conventional network, grid connected system, thing is that, sir, still now we not tested our algorithm.
Any questions from the audience, please?
Hi, thanks Mr. Bhaumik for your presentation. I'm Aditi, and my question is that have you taken into account the parasitic capacitance between that gets formed between the PV and the ground, and that can cause some leakage current and potential grid current distortion in your
I
algorithm?
think you say some high impedance fault, the PV fault or leakage current, that
Yes,
is high impedance, means the impedance of the system is not just like a conventional system. It is a fault, but with some high resistance. So no, it is not considered here, but in upcoming our further study we can definitely consider.
Right. Okay. Thank you.
Thank
so
you.
much.
If we look at most of the microgrid investment is very low, okay? When you are implementing for any residential complex, small industries, etc. Here, wherein that our investment for automation part in this microgrid controller, very low cost thing we consider for that. But your solution which you are talking, whether it is compatible to that, I mean cost or not. Do I have to invest very low amount to protection for this grid or whatever, because my overall investment is very low, so I cannot invest much for the protection for that. Is it compatible to that?
Sir, actually we tested this model in very low voltage module. Okay, it is something volt, means not kV, very low voltage, because our laboratory setup is not so high. So for this reason we need some one type of controller, and this we collect the data from whole sensor and other things, and we as laboratory setup we can totally executed in hardware level also. But what is the cost in case if I don't know the voltage, proper voltage level, and another thing, it is very difficult to say. In laboratory setup, we need some sensor, and the programming is also burned in chip, so it is not some very low amount. But thing is the total, if you say the in feasible or reality or big sector or high voltage or 440 volt, we'll still not test it. But I think it is not so much high, the cost of so much high, because we collect the data, the current data, single point. So if you consider anywhere, you can use your automation anywhere, any point of the grid. But we can collect the data from PCC only. So if it's 9 bus, so 9 we don't need the collect data from 9 places. We need collect data from 1 places. That is single point measurement. That is one of the unique feature of this study. So I think it is cost saving, because the main thing is current, and we take the current data from one place. Another thing is that in case of protection purpose, there are a lot of method you can say that they take current, they can voltage also. But in our study, we only take only one parameter, that is current. So if we consider this thing, I think this is cost saving.
Is it possible to embed with the microgrid controller? I think that could be best solution for this.
Okay.
Thank you.
Thank you, sir.
Now, the issue comes is, you see in a larger grid, you have all the protection and all kind of monitoring and systems. Where you have not put much of money,
Yes.
early fault detection and rectification will also be of importance, especially when there are laws enforcement about consumers' rights, that their electricity must be restored in a particular time. So probably this system will help us in abiding by the law without making much investments on protection and monitoring and all those systems. Probably this could be a viable system. Okay, thank you, Mr. Bhaumik.
Thanks.
Next we have Mr. Dheeraj Gangadharan from Accenture.
Hi everyone, good morning. I'm Dheeraj Gangadharan and I'm honored to be here at ISUW 2025. Today I'll be discussing how generative AI is transforming the utility sector. In the next 10 odd minutes, I'll cover what Gen AI is, the current market context, its relevance to utilities, key application areas, potential risks, and takeaways for a typical utility firm. So what is generative AI? Generative AI represents a revolutionary class of artificial intelligence capable of learning from and mimicking vast data sets to create new content based on prompts or inputs. The large language models, which are basically machine learning models that can understand and generate human language, form the basis of generative AI. Think of these models as powerful engines that can process large amount of data. It can be text from Wikipedia, voice notes from podcasts, images and videos from YouTube, code from platforms like GitHub, and so on and so forth. So these models take these as inputs and provide you with valuable outputs, answering complex questions, generating summaries, writing code, and creating content, as well as automating processes. What makes Gen AI particularly valuable for utility industry is its multimodal capability. It can handle text, structured data, all in one framework, which is basically very ideal for an industry like us, where we have diverse operational requirements. Now, looking at the market context, the growth trajectory of Gen AI in utilities is remarkable. By 2033, the market is projected to reach approximately $1.33 billion, growing at a CAGR of 34% from 2024 to 2033. This is part of the broader AI market expansion, which is expected to surge to $2,800 billion by 2032. What's particularly striking is that over 50% of organizations have increased their Gen AI investments in the last 10 months. For the utility sector specifically, it's noteworthy that 54% of executives view Gen AI as critical to advance their green energy initiatives. And approximately 40% of utility companies have already established dedicated teams and budget to explore Gen AI capabilities. So for utilities, GenAI couldn't arrive at a more critical time. We are facing multiple transformative trends. For utilities, customers, especially large ones, need innovative solutions like demand response programs and energy management platforms. GenAI can power these personalized services. It is a well-known fact that the regulatory landscape for our industry is increasingly complex. GenAI offers robust data management, data aggregation, and automation capabilities that can help navigate these challenges. Optimizing energy production and integrating renewables are now essential operations for us. GenAI enables simulation of operational scenarios via LLMs that were previously impossible. Grid modernization and energy transition are at the forefront and require us to revamp our capital projects processes. Also, integrating EV fleet services is a must. GenAI can help via assisted design and planning and streamlining documentation as well as demand prediction and fleet management. In addition to this, prosumers demand clean, reliable, and affordable energy now with personalized experiences. GenAI enables a 360-degree value management for these sophisticated customers. Lastly, energy trading requires real-time analysis, risk management, and autonomous trading capabilities. All these areas is where GenAI can support seamlessly. Let's have a broad look at the 5 critical themes where GenAI is delivering measurable business value. Operations and maintenance, where GenAI-driven project design, preventive maintenance, and load forecasting reduces cost and downtime. Grid optimization and resilience. GenAI augments enhanced asset integrity, helps in damage assessment, and automates work orders to improve stability and efficiency. Customer engagement. GenAI integration in intelligent chatbots, billing management, and marketing boosts customer satisfaction and sales. Energy markets. Market analysis and contract automation via GenAI optimizes revenue for the firm. Last but not the least, sustainability. GenAI-driven ESG reporting, supply chain decarbonization, and carbon credits management accelerate the sustainability vision and compliance. Despite its tremendous potential, GenAI implementation comes with 4 key risk categories. Unreliable outputs that talks about issues related to bias, insufficient transparency, and inadequate accuracy. Privacy and security that includes vulnerabilities and potential exposure of confidential information. Liability and compliance addresses concerns about intellectual property rights, regulatory compliance, and contractual obligations. Unethical usage is a potential for disinformation, harm to vulnerable populations, and malicious misuse. To mitigate these risks, utilities should define and communicate a responsible AI vision with C-suite endorsement. They should also ensure adherence to regulations and implement comprehensive risk management strategies. Develop and embed tools and methodologies in systems to uphold accountability and privacy. Lastly, foster leadership commitment to ethical AI and provide comprehensive training to employees. This slide gives us a view of the important use cases of generative AI across the utility value chain and support functions. Key use cases include process optimization, predictive maintenance, workforce automation, grid management, personalized energy services, financial reporting, and intelligent procurement, among many others. This list grows every day. Embedding this technology accelerates efficiency, resilience, and customer centricity within the entire ecosystem. As I conclude, let me leave you with these key takeaways. First, generative AI represents the forefront of digital transformation in utilities, offering capabilities that extend far beyond traditional AI applications. Second, the benefits are substantial, from significant reductions in equipment failures to major efficiency gains in system optimization. But successful implementation requires careful navigation of security, data, and workforce challenges. Third, Our industry's highly regulated nature demands a balanced approach to innovation and reliability. Utilities should focus on investing in AI talent and tools, building GenAI capabilities in-house, and leveraging external models where appropriate. Finally, ensure that AI solutions are scalable, adaptable, resilient, and aligned with long-term sustainability goals. Thank you for the attention. I'm happy to take your inputs and insights.
Thanks, Dheeraj, for a very nice presentation.
Thank you, sir. Thank you, sir.
Well, you have really nicely highlighted what is the use of generative AI in the entire value chain of the power system, right, from generation to the end consumer. And you have also underlined what could be the probable risks
Correct.
and threats which needs to be addressed while implementing it. That's a word of caution.
Correct.
That what we should do. And probably over that period of time when the whole thing will mature, things will definitely work in a much better way than what is being conceived today.
Correct.
So there will be a lot of protections and everything will put up that no data leakage takes place. So any questions from the audience, please? It seems your presentation is amply clear, so there is no confusion for anyone.
Thank you so much.
Okay, there is some confusion in that.
Yes, please.
That's some question.
You had load forecasting as one of the use case for Gen AI, right? Now, normally for a power systems engineer, that's time series forecasting. You'd use an ARIMA method, or you'd use an ANN, for example, right? Why is it Gen AI? Because I think there's this tendency of pulling multiple things into Gen AI, right? So for example, one of the cycles was pulling well-known power system methods into machine learning, right? And now we are seeing AI actually being pulled into Gen AI. So I just wanted to understand what is the boundary really, right, for Gen AI? Because I would think one application is where it's essentially an advisory, right? So you already have a wealth of data.
Correct.
You're trying to pull insights out of it.
Yes.
Right? So my question really is, where do you draw the line, really? Right?
So to answer your question, basically there are overlaps with respect to many domains. Load forecasting, as you mentioned, it's nothing but analyzing the historical trends, right? Just providing LLMs the inputs of the entire historical patterns of data that you have collected across the years, and GenAI will just analyze it and provide you, the forecasting of, whatever data you have provided. So in many domains, what I have researched, I have seen that there are overlaps, and there is a very thin line between, the typical AI models that we used to use and the LLMs, right? As I mentioned, LLM is another machine learning model that we are using. It's just that it allows you to basically, input very large volume of data, right? Which was previously not possible with a, with a conventional AI model, right? That is the only difference that I see in many of the domains and where this overlap is.
Thank you.
Thank you. Thank you so much.
Next we have Ms. Najda VM from TNEI India Services Limited.
So, warm greetings to all. Myself Najda, I work for TNEI, a specialist energy consultancy having global presence. I am here to present our work regarding a simplified network model management framework for load dispatch centers. So, we are in an era of regulatory transition in power system. So, historically, we were operating as a vertically integrated structure with 4 main domains like generation, transmission, distribution, and consumers, with simple interactions between them in terms of power flow, data flow, and finance flow. Then came the initiatives for decarbonization, decentralization, and all. These initiatives were to have a better future in this planet. These initiatives has led to restructuring of our grid to several stakeholders having complex interactions in terms of these energy, data, and finance flows. Moreover, these complicated structures are interconnected to form a large, vast, interconnected grid. In this scenario, system operators are facing several challenges. Some of them are listed here. To meet the net zero targets, large scale generations and demands are being integrated to the grid. Then vast interconnected grids with dynamic generation as well as load. Then multiple independent stakeholders having complex interactions. And again, the big data. Now, to address this challenge, we need solutions as for system operators as well as for the stakeholders like aggregators, independent power producers, discoms, etc. And what happens is like these solutions should be interoperable to have exchange of data and information between them to have a harmonious operation of the grid. So this necessitates interoperable solutions, and these solutions can pave way to digital twins of our power systems. So going into detail, to address the challenges of this era, system operators requires advanced power applications to have a reliable, resilient, robust, and economical grid. And this power applications has to operate on data-rich environment from multiple data sources, and they has to operate in harmony. To ensure the harmonious operation, we need standard representation of power system, assets, and how they interchange data between these solutions. One such standard representation is in the form of SIM, which is known as Common Information Model, which is an abstract class representation of power system model. This was first developed by EPRI as Control Center Application Programming Interface. And many of the international agencies has identified it as the foundational block for developing virtual representation of power system, which is nothing but that we call it as digital twin. And this standardized representation of power systems allows vendors to develop interoperable solutions, especially in terms of power system analysis and visualization, and the solutions that handles power system models, scenarios, sensor measurements, etc. And also to develop decision support mechanisms. Coming to that, this SIM, which was first developed by EPRI, has evolved into 3 sets of IEC standard series. Coming to the relevance, this SIM-based representation of power system allows to have model exchange among control centers within a standardized form, which the applications could be expansion planning studies, operational planning studies, outage management, load shedding schemes, etc. Then it allows to exchange models under various scenarios like pre-scheduling, real-time, post-settlements, etc. And the standard way to exchange model and related informations allows vendors to develop solutions which are interoperable with each other. This enhances the scalability and flexibility of the entire system. Moreover, the SIM allows to have extensions to meet country-specific requirements. Based on that, ERCOT has developed a standard representation for their power system models, and SOE has created CGMES for their representation. Coming to India, we were operating as 5 different regions before, and we have now operating as a single grid. How we overcome the different representation of power system models by 5 different regions previously was by replacing with a vendor-specific software. Now, we are in a scenario to interconnect with other neighboring countries, and in near future we will be having, and we envision to have a South Asian network. So in near future we will be expecting to have a consortium of network operators to share the information between them. So we need to have a standard international form of representation of our system to exchange this information against the system operators of this region. Moreover, the International Solar Alliance, we have enormous vision of one sun, one world, and one grid. So we envision to have a transcontinental power transmission grid. To implement this, we need to have a standard representation of our system that enable us to exchange information relating to the model, measurements, and studies being conducted on that. So, regarding the SIM implementation plan, Professor Kapate and his team were pioneer in India. Their focus of study was the SIM implementation in scheduling applications. Moreover, the team has identified the relevance of SIM-based model authority set to have regional and national level SIM network. These pioneering studies has developed to adopting a IS standard series of 16336 series, which facilitates SIM-based interface specification for application vendors. It also identifies country-specific information exchange use cases for SIM implementation. It also provides extended model exchange profiles for information exchange. As I mentioned earlier, since the pioneering work were in the scheduling application domains, these specific extensions was specified for only the scheduling application domains. But the part 3 of the standard identifies inter-application interactions at RLDC levels and presents some use cases where SIM could be implemented in India. So this work has identified those use cases, a subset of that use cases, to propose a network model management application. So that use cases as represented as you see here, and those numbers are represented here. So a subset of those use cases are identified to form a network model management application which interacts with several business processes of load dispatch centers. So this work proposes a SIM-based network model management application, which is nothing but an integrated repository of power system models. So all the LDCs can interact with a centralized repository of the power system models with other agencies like ISTCs. So what is the advantage is like all the operations will be carried out on an integrated repository, which reduces job redundancy and allows you to conduct studies on a real-time model, which is getting updated frequently. So this applications allows you to enroll the organization levels, like as LDCs could be enrolled as organization, then job roles and organization roles could be specified. Based on this organization job role structure, you could have access level permissions to the network models, and there's process and sub-process like network model creation, updation, exchange between different entities. Like if you want to share alone the load flow results, that will be possible and will also be configured accordingly. Moreover, workspaces could be provided for these business applications and dashboards for holistic views. Then this timeline tickets allows you to have a responsible model exchange between the applications and so on. So the use cases are like ERCOT and NDOC has adopted SIM as a standard for their model exchange between different platforms of control centers. And China has also adopted SIM, and they have been using it for exchanging model related information between their automatic voltage control system and the EMS of control centers. They also have a network remodeling system which acquires network models from regional control centers and do build up of network model at the provisional control center. Then this NSTAR, investor owned utility, adopted this to have exchange with NSOE. Then CAISO has also adopted SIM for information exchange between the market and grid applications. So the key takeaway is SIM, which is the standardization of information exchange based on the power system model and related information, which allows you to create interoperable solutions. This coordinated model management allows to reduce job redundancy, which is happening at different levels of LDC operations. Availability of updated EMS models to different business process allows you to have a realistic study on your model, and it allows you to develop vendor-independent applications which promote competition among different vendors and enhances scalability and flexibility of control center applications and serves as a stepping stones towards the digital twin. So this is the proposal of this work, and these exchange models have been, exchange profiles has been identified in terms of CGMES, but for our country-specific requirements, we need to have a collaborative research with system operators to develop our country-specific model exchange profiles to implement these types of solutions. Thank you.
Thank you, Dr. Najda. It's a very nice presentation, and this is the need of the hour for having a common information model for a better control, better integration, and better operation of the total power systems. And its importance is increasing with what's in thing is that one sun, one word, one grid. Probably not only the information which have to be standardized and put on a common platform, we may have to put out a standard time as well. Because when we are talking of a one word on the same grid platform, then every information should correspond to a same time frame. Just like the aircrafts are moving and their time zones, what we know by the schedule is different, but for the traffic controller and the pilot, the time are different on which they work. So probably something kind of that model will have to be introduced in the CIM system. Any questions, please?
I'll just mention that SIM is adopted widely. It's not just that list. So SIM 15 and 16 is standard now.
Yeah. EMS application vendors are adopting SIM as an open source standard.
Yeah. And my comment was, I know that wasn't part of your presentation, but the commercial model, which is needed for market applications, for example, right? Is there any work on standardizing that? Because that is a challenge.
Yeah, right. Market applications. Correct. So my work was focusing about model exchange between control centers.
Okay, okay. Yeah, because you had one on KISO markets. So I just wanted to understand if there's some work in trying to standardize the SIM for markets also. Thank you.
Thank you, Dr. So next speaker is Mr. Priyanshu Agrawal. Priyanshu Agrawal.
Priyanshu Agrawal from Cognizant.
Yeah. Hi. Good morning, everyone. Thank you. So the topic of my presentation is governance framework for GenAI in utility, sustainable utility management, an ESG perspective. So the utilities sector is under pressure to address climate change, ensure equitable access to energy, and maintain transparent governance. So there are multiple challenges in this. Let's first bifurcate the challenges. First is a climate challenge. In climate challenge, there's extreme weather events, like there are extreme heats in some area and floods in other. So the utility system should be, robust enough to handle that changes. Second is a transition to renewable energy, which requires investment, and as well as there are limitation in every energy sector. Second major challenge is the equitable access to energy. So where there's a need for robust infrastructure development, and second is the affordability, that it should be affordable enough. Third is the maintaining transparent governance. So in this, there are two major factors. One is the regulatory compliance, And second is the stakeholder management. So in stakeholder management, mainly government agencies are involved. Okay. So, so here these challenges are there. Now we need to see how we can try to solve these challenges as much as possible. So GenAI emerges as a disruptive technology capable of addressing these inefficiencies, driving stakeholder management, and ensuring robust governance. So in this slide, I have mentioned how GenAI helps to address the ESG challenges for sustainable utility operation. So let's start from the left-hand side. So these are few solutions. These are not comprehensive list of solutions which are covering in and all of utility challenges, but few major solutions which I have mentioned here. So first is addressing climate changes. For this, one solution can be the predictive analytics. So where Gen AI can drive the forecast, energy forecast, and based on that we can optimize the operations. So this, we can train our model and then we can give it as a solution. Second is a renewable energy integration. So where we have renewable energy in different sources, we need to integrate into the main grid. So Gen AI can help in the integration of these energies. Second is a social challenge. In the social challenge, so if we have to ensure equitable access to energy, so there will be an infrastructure optimization. In the infrastructure optimization, Gen AI can help. We can develop the models, train it, so that we can optimally use the infrastructure. With bare minimum possible infrastructure, we can distribute as much energy as possible. And second is the most important is the cost management. So we are already, in a very, our cost is very increasing in the utility operation. So how to optimize the cost operation? So we can train Gen AI models for the cost optimization part. Next is the governance. So in maintaining transparent governance, the major issue is the algorithmic transparency. So as everyone is saying, like, let's implement Gen AI in different parts of the business. So the models are getting complicated, and in the complication, it is not possible for the user to understand whether those models are transparent and correct enough or not. Basically, models are trained on the data. Okay, so there is a need for explainable AI layer on the top of Gen AI layer, where we can see the level of transparency and the accuracy of those models. So we'll discuss this topic in detail in the future slide. And last is the regulatory compliance. So Gen AI can, we can develop models which can help in the monitoring of different regulatory compliance points of any utility operation. So these are the few solutions, as I said, and now these are the solutions. Now, if we go through the implementation of these solutions, we need to see what are the challenges are there for the implementation of these solutions in the utilities. So these are the few basic developments in India which is going on in this space. So NSAI, National Strategy for Artificial Intelligence. So it is, first version is released in 2018, then last version, some modification were done last year in 2024. So where it is identified that energy is a sector where we require a Gen AI intervention, and it advocates it to enhance energy solutions for energy efficiency and management. Okay, along with assigning, along with ensuring that AI principles to ensure transparency and accountability in AI applications within this utility sector. Second is the use of AI in the energy management. So Indian government is exploring opportunities where they can use AI in the energy management system to optimize the operations. Okay, and third is the renewable energy integration. Now, these are the governance challenges in the ethical AI deployment for utilities. First is the algorithmic transparency and bias mitigation. So since in any AI or Gen AI models, these, especially Gen AI models, these are trained on some set of data. So when we need more features in the models, the complication increases of that model. So to identify whether those models are capable enough or how long they are capable enough to support us in executing our work, we need we need to have some kind of check where we can see whether this model is usable as of now, or we need to upgrade that Gen AI model. We'll come on this particular topic in the next slide, where we can see the solution of this part. Second is the data privacy and security. Since in utility, there are a lot of data which is used in terms of transaction, in terms of geographical data, consumer data. So we need to ensure that whatever data we are using for model training, that data, is not going into the wrong hands. It is safe. It is safe. Okay. And third is the regulatory compliance and accountability. That if there's so we need to adhere to all the government guidelines to ensure that we are working as per the regulatory guidelines. Now, this is a path for ethical AI deployment in utilities to meet the governance goals. So first, we need to establish an ethical and standard policies. We need to develop an AI ethics guidelines and form an AI ethics committee. Okay. Next is the algorithmic transparency and explainability. We need to implement an explainable AI. So this is a topic where I want to focus here. So any GenAI model which is being implemented in any utility, it should have an explainable AI layer on top of that. What is the reason of having this layer is, once this layer is there, so as I said, these models are very complicated, not possible for any normal user to understand all the complications in how this model is developed or trained. So this explainable AI layer will help you to understand how this model is biased or not, or we are failing to deliver any KPIs through this model or not. So this is a kind of reasoning on top of GenAI layer which should be there. Okay, and regular audits and reviews. It is a normal practice. Third is the data privacy and security. So where we need to adopt the robust data protection measures, and we should go for decentralized data management system. Then is the regulatory compliance and accountability, where it's mainly the stakeholder involvement. We need to connect with government bodies for this. Then it's a continuous monitoring and risk management. So we need to have real-time monitoring systems and risk management strategies. And last is the training. So where we need to do employee training and consumer training who will be using these models. So here's a success story which we have implemented. Which we have implemented for a leading insurance provider. So I was not able to get, to be honest, in utility, but so the one I'm able to get in insurance providers, I'm sharing here. So the customer ask was they want to develop and deploy an AI system that adheres to guiding principles of transparency, explainability, and fairness. Okay. And the company, since it's in insurance industry, the company faces significant challenges in ensuring these principles. And they need to adhere to the local AI regulators for this. And once a model is developed, so you know to convince all the internal stakeholders within that company so that we can get the project. Now, what are the solution highlights for this? In this, the company developed all the, our company, basically, we spoke to all the stakeholders externally and internally. We identified what solution, what are their pain areas and what are the solution which we need to deliver them. And then we created a customized AI framework for them, which has some more than 100 checks, so that those compliance can be adhered. Okay, and we are able to deliver the solution to the client. Thank you. So in conclusion, so GenAI has a potential to revolutionize the utility sector by addressing the inefficiencies in the value chain from the generation to the delivery and customer service. But through ethical governance frameworks, utility companies can harness GenAI capabilities responsibly. Yeah, thank you very much.
Thanks, Priyanshu, for a nice presentation.
Yeah.
Now, AI, we are depending too much on it. But my understanding is that AI has its own limitations.
Yes.
It can only offer you solutions to the extent the response it has been fed with or programmed for. Any new thing coming in, probably AI will not be able to.
Concept presentation.
So it needs what you also mentioned, that is timely upgradation, time-to-time upgradation, studying, and also to always keep a check on what kind of inputs it is getting, and whether there is a deviation in the inputs and the response.
Yes, exactly.
By actual individuals, experts sitting onto the system.
Exactly.
probably that kind of a coordination interaction will be required to have a more effective usage of AI and its development. Because every now and then some new things will come up, whether it's a regulatory, whether it's a operational, whether it's a system requirement, whether it's a type of generation, and even sometimes even the behavior of the consumer itself will have impact on so many performances. So I think that's a close link between AI application and the human interface.
Yes.
They have to run hand in hand for a really most efficient operation system.
Yes.
Any questions, please, from the audience? Yeah.
Yes, sir.
Hi, Priyanshu. One question is with respect to the biases, right? You mentioned that AI could have some biases, and in that regard, what kind of bias have you experienced in your research on the AI on the utility side? What could be the potential biases that could come up?
Okay, so the reason of bias, why I said is, the GenAI models are trained on some set of data. Okay, let's say we are implementing a GenAI solution to a particular utility. The utility gave its data from for a certain time period, for 1 year, let's say. So based on that 1 year data, the GenAI model is trained, and then that model is being used by the utility people. Okay, now the result of that GenAI tool is coming based on the data it is trained. Now maybe it may happen that not all the events are covered in that 1 year data, so it is not that comprehensive. Okay, so solutions are coming accordingly. But the end user who is using that GenAI model may not be aware on what kind of data it is trained. That person is just seeing the result and using it, saying that it is coming from this tool. Okay, so then it comes for the checks committee that they need to check on what kind of data it is trained, and that it needs to be trained regularly in some like 6 months or 1 year. Every 1 year it needs to be trained. So that the model becomes more comprehensive and giving you the right result, unbiased result. That's a thought of unbiasedness. And when you put a layer of explainable AI, look what happens, like in the market, people go for GenAI solution. Nobody talks of explainable AI right now. Once you go for that explainable AI layer on the top of GenAI layer, then you can see the biasness of the data. There you can decide whether this biasness is okay for me or not okay for me. Okay, so this is on a thought perspective. Like we have not, to be honest, we have not executed any order of explainable AI. So otherwise, I would have given you some biasness thing what you are asking for. So this is the answer actually I want to give you. Thank you. Yeah. Yes, ma'am. Thank you, ma'am.
You mentioned in the context towards the end ethical governance. Now there's no regulation.
Yes, yes.
So where does the ethics come in? How are you going to ensure that? It
So,
seems very difficult.
Yes, you are right. So, ma'am, first of all, there are two ways to answer this question. One is the government needs to step in and form some kind of standards, okay, which all utilities or companies in energy sector can follow. That is the one solution. Till the time that is not happening, then the individual company needs to take those responsibilities, and based on international standards, they need to form their own ethical guidelines, so that we will implement those things. Because in future, whenever government will implement, they are already adhering to it, and they are ahead of the competition at that time. This can be. They are there, but they are also developing on year-on-year basis. Nothing is very formalized anywhere, but yeah, they are far ahead from us, kind of. Thank you, ma'am.
Thanks, Priyanshu.
Thank you, sir.
Thank
you.
I would request Mr. Anil Kumar Oja from PPWODL to make the presentation.
So, very good morning, today presenters, today delegates and jury. So, my topic is related to that process automation related to the master integration data what we did for our smart meter. Okay. So, just give a background that we are just 4 years back from utility. We had just started our journey in 2021 January, and we are basically serving a customer more than 20 lakhs over there. And we are spread across 50,000 square kilometer area. It's a very big size in terms, but the load parameter we talk, it is just a 15 to 1800 megawatt a peak load we serve over there. So we have basically 9 revenue districts and 5 distribution circles, and there are further administrative boundaries have been created, like division, subdivision over there. Recently, we got last 3 years we are getting A+ rating through the Ministry of Power related to the integrated rating over there. So if you see that what's happening, if we talk related to the effect of AMI in ecosystem, so utilities are going to bring the more accurate data related to their consumers, even though the load forecast and other parameters is going to happen. Similarly, that the transparency is going to come between the customer and the stakeholders. Because when to talk the stakeholders, I'm talking related to the regulators, consumers, and the partners as well. Accountability is going to fix because the smart metering is not only a billing to customer relation, it is going to bring every data to upfront and on the part, and the responsiveness is going to increase over there. The last and not the least one, that which is basically a missing component in today, if you talk on the value chain of distribution, is the trust building. Because none of the customer, if you talk in general, if I talk 5-year back data, the customer very apprehensive related to the billing, so whatever data you are providing to them related to power supply and others. So this MI is going to bring that trust building amongst the ecosystem over there. And if you see this, because this is not the end, because this, whatever is going to happen through the smart metering, and if you see the, just we are the private utility, but there is an initiative from the government of India through RDSS that many states are doing this reform, and I wish that this reform is going to take place so that there are silent drivers that are going to come in between. And these drivers are going to have, like, effective communication is going to be developed, it's going to be driven. So the agile response is required. And the consumer empowerment is going to be happen through this technique, and obviously the just-in-time service is going to be one of the parameters. There are, one thing is happening related to rooftop solar where the discoms may think a threat, or I'll say the different way, the consumer is going to be self-sustenance model. So if you see all this silently is going to be developed down the line, there required enablers to take care of the forward path. And the forward path is going to have the deployment of technology in such a way that it should have a ruggedness related to the infrastructure. It's either you can have in-prime solution, if you go on cloud solutions, it is required. The processes which have been built, so I'll say, the automation is not the journey or the end. We need to build intelligence above it. So the process automation is going to be key to drive on that part. The effective handshaking, because the earlier presenter had mentioned related to SIM formation, SIM data format and others. So we need to make a standardization of the data format where the handshaking can happen with the various systems. And obviously, at the end, the grievance handling to the consumers so that the end, so the service provider, because the consumer is a king, we need to serve them over there. So I'm just giving a very simple example related how the smart metering phenomena works and how we had deployed RPA, though there are multiple, very complex in nature, where this the smart meter is going to use for our load forecasting data, the smart meter is going to use our outage planning of the particular area, demand forecasting, everything, consumer behavioral pattern study as well, everything. But I'm just giving an example that how today the scenario is that we have basically deployed 4G based smart meters, and these smart meters connect to our head-end systems. Head-end systems sends the data to MDM, and there are back-end system called billing system or billing engine, which is CIS for the consumer master. The challenge is that when you deploy these solutions over there, it is required need to be hand-checking to all together, and then it was basically activities has been performed over there. So if you see the complete activity, it has RPA has played a role in every segment of the term. Like you start with the billing cycle. The billing cycle in TPWDL was almost for 3-phase consumer was 15 to 20 days. After implementation of complete smart metering and the processes, the billing cycle had reduced 3 days. So today we bill all our 33-phase and the single phase, because smart meter we had deployed only 4 lakh of smart meter out of 20 lakh of consumer was what we have, 20 to 21 lakhs. Now we are getting less than 1% billing error on that parameter. Earlier the billing error was, if you talk, it was more than 13 to 14%. Similarly, because once we have a prompt billing and the correct billing, what we consume and you pay for it, we are getting a very good impact on the collection phenomena. So collection we had increased in multifold in terms of we have seen in the past trends. And the third point is that related to if we give the customer billing on the right, normally the billing is normally utility provides, but providing a slab benefit is one of the factor, because if I get a slab benefit, I get a less bill. Because if the days change from 30 to 35 and 40 days, there will be change in the slab and the consumption is going to be more. In that terms, the people has to pay more payment to them. Similarly, because as you mentioned, because we have to face the end customer, it is very necessary that the customer should respect us. And it is only what's going to happen that they trust on us, and this gives a satisfaction apart from the whatever you're getting a benefit as a part of the perks and salaries. And the fifth one is that how this process automation has been bring, and the piece of the segmentation where we bring related to how the billing we are providing over there. And nevertheless, the quality is the paramount is going to happen once we do this kind of activity. And today we can say that we have 3 phase, we have less than 1% error, and similarly for single phase, because we have more than 14 to 15 lakh meter is still there in the manual mode, so the error are 2% approx. Yeah. So what we did, because we had brought the systems in a different platform, so it is required to how we can standardize this activity. So before integration, we try to finalize the parameter that how the exchange is going to happen within the systems, how the data exchange is going to share. We develop a tool for that purpose and ensure that the testing should be successful, because it is required to test in the various scenarios. So what we deployed, what we do over there, and after that we had fully deployed the solution on our system over there. So if you see in that term, the challenges were that we have multiple scenarios, multiple systems. And those, though we say that we follow DLMS protocol in the part of metering as well, because today we have a single HES who take care of more than 4 kind of meters, which was not possible in general. Everyone comes with that solution that take my meter, take my HES, and do your integration. And we had already a struggle, but we decided that because you do not want to go in that terms, so try to finalize that template. Today what we do, whatever new agency comes for through the tendering, we try to basically give our own DLMS template to them and try to ask them to make their meter in such a way that we get the data in that same format. So earlier it was not there. We tried to make that happen, that all the standard should follow on that terms. And further, the data which is coming, because as you know that metering data is coming from the each individual, and that data is going to be punched through a software tool. Through there, where the data is coming to, normally you say the protocol data shifting to the data to our master's data over there. So data which is coming from the different individuals, though the possibility of having the error, because it is again a manual punch. So we try to implement that the cross check, so that the tool should give some errors, and if any abnormality is there, can be identified for that purpose. And then further development tool from the CIS to MDM, MDM to HES are through a seamless process has been developed on that. So earlier this was a scenario where activities are complete manual through mapping. Now we are using a process automation where we're bringing the data, and we just started the journey. I'm not saying that we had matured such enough that is going to be happen, but yes, we had started moving the mechanical data around. It is going to happen that build intelligence over there. Like earlier presenter mentioned, AI generation and others are going to happen in the utility as well the segment. It's not the insurance segment. Power segment is today, though the discrete systems are there, different products are there, but today is an integrated way, and we have to go beyond. We are trying to bring that the way is the scenario that how the ecosystem should help us to provide the right solution on the right time of the activities. So if we talk particularly in terms of the benefit, as you mentioned that the bill accuracy is more than 99% we have. As we mentioned that we have believe efficiency has increased of the record. Similarly, the cost saving, because operational efficiency is another parameter, because we are a regulated entity and every penny spent through whatever means has to be accounted for. And as you grow, We are bringing new technology, manpower and everything. Systems are increasing day by day. So need to factor in that how we are going to bring the reduction in the cost parameter over there. So manpower saving we here try to achieve over there. Billing cycle has gone reduced over from every month is closing by 4th, which is going to take more than 20 to 25 days of next month over there. And satisfaction of both the consumer and employee are related to that. So this is just a trend. If you see today, out of our 20 lakh customer, 4 lakh customer are going to build, which is 40% of energy. If you see the trend in that, 40% energy we are billing through the smart meters, though the quantum of smart meter is only, I'll say, the 20%. So that we need to think that how do we make the investment on that part. The phenomena is going to be happening in such a way that the smart meter is going to be key change and driver for the utilities. And this need to be deployed in a very systematic manner. It cannot be done in the halfway, because even if you do the process or in the engineering of only a smart meter, it's not going to serve the purpose. So the utility need to focus that how this smart meter further going to have embedded with the other system like your call center, your outage management system, your the others application of your maintenance activities, so that you can decide that if the power fluctuation is happening, low power segment are happening, that can bring a complete ecosystem for that purpose. And I'll say that more, this kind of process automation are need to bring out so that this cannot be manual intervention, even though the processes are there, if you do a kind of a simple automation in that terms. So this was just related to the award and recognition we got. We recently got the award for QC, which team is going for the international activities. Yeah, thank you very much.
Thank you, Mr. Anil, for a very nice presentation. Now I have one issue. Is AI and robotics, do they complement each other? Or they are a standalone solution to our systems?
Sir, I will say it's a subset. AI you can say, or it's a, because I'll say that robotics is physical robotics, I'm talking the process software. So AI is, I will say, the bigger umbrella, where this process or automation or robotics, whatever you say, is going to fit into it. It is going to complement to each other. It's not that going to have kind of, because what we did today is more on the side, remove the mechanical activities. Now we have to build the intelligence over there. If something goes wrong, how you are going to take action, because someone is required a response today, 12 night, I want to check my consumption into the pattern study. So I need to understand that this requires kind of analytics, which is going to further build on the AI model. So it is going to complement to each other.
So basically, AI is an information generation system and robotics is the action part. Can we take that?
So both, it's the way of you deal it.
That means it takes input from AI, because basic data has to come from somewhere for robotics to act. So are we going to say that the basic data will come using AI and robotics will analyze and tell what are the possible solutions, or even some areas where we define that you have to take action, it takes action?
So I'll say the different way. Yeah. The robotics is a kind of the process of doing the activities. Again, it's a part of AI, because you're bringing some intelligence over there.
So this is a subset of AI basically?
Yeah.
Which is subset of whom? Whether the AI is subset of robotics or robotics is subset of AI?
I'll ask if you ask my point of view, maybe correct or wrong, I don't know. But I'll say this AI is the bigger umbrella, where the robotics is going to fit in.
Okay. Thank you. Thank you for a nice presentation. Any questions please from the audience? Nothing.
Okay. Thank you. Thank you very much.
Yeah, Mr. Ajit Kumar Singh from the Energy and Resources Institute.
Hello, good afternoon. My name is Dr. Ajit Kumar Singh. I work at TERI as Associate Fellow in the Electricity and Renewables Division. So today I'll be presenting you the outcomes and the insights we had while implementing a pilot on the digital twin technology So we implemented this pilot with, as a consortium partner with BRPL. The digital twin technology was provided by Vinos Energy Platform, which is a German company. And it was under a funding by United Nations Environment Program and International Energy Agency under their Digital Demand-Driven Electricity Networks 3DEN initiative. So the focus of this presentation will be to explore the challenges and opportunities of distribution grid analytics in the Indian context, although much has been already said in the house, and I'll be just adding my 2 cents to it. And we'll explore the digital twin technology and how it can help in the integration of renewable energy in the Indian distribution system. We'll also focus on some learnings and the future recommendations. As a case study, we'll present the work which we have already done and how it can help in the more suitable integration of renewable energy technology. So looking at the challenges in the Indian distribution network, all right. The India is a growing country. The population is increasing, the purchasing power is increasing, and accordingly, we are becoming more of a power-hungry nation, energy-hungry nation, and the demand of the electricity is increasing like anything. And from the supply side also, we are making a lot of initiatives, and so once the supply increases, the infrastructure also needs to be upgraded, right? On the other hand, what is happening is while we will implement this pilot, we see that many of the consumers, they have shifted from one phase to another phase without even the consent of the distribution companies. So they were not even aware that how much of the consumers are connected to which phase. So this leads to unbalancing of the phases as well as the capacity, the total capacity of the distribution transformers remains unutilized. Again, non-technical losses, energy theft, they were there. They are still very much relevant today as well. Another challenge is the seasonality of the electricity consumption. The Indian peak is quite unique. Indian demand curve is quite unique. We have 2 peaks. And apart from that, the AC penetration is also increasing. Currently, we have only 7% penetration. The report suggests that soon we will have around 40% penetration by 2050. So very soon, the electricity demand will be, the dynamics of the demand will be governed by air conditioners. So we need energy efficiency and cooling demand response programs. So in order to meet this demand, we need infrastructure upgrades, but especially in the urban areas, we have very limited space for expansion of the distribution network. We're talking about the relevance of the digital twin technology. So we know that India has made very ambitious targets of integrating 500 gigawatt of non-fossil fuel by 2030 and net zero by 2070. Electricity demand will be growing by 1.5 times of the present value by 2031-32. So the infrastructure must balance the economic constraints and space limitation in the urban areas. So very soon we'll need a lot of monitoring. Monitoring will be very much required. And so here, digital twin technology appears as a potential solution for improving grid transparency, operation, and planning. We're talking about the monitoring in the Indian context. So we have a transmission system, we have distribution system, and the medium voltage range. So the transmission system is generally very much, it is very much organized. It is very much kept into the observation by means of EMS or the, now we have got PMUs, SCADA also. So they are very much, observability is good at the transmission level. On the distribution, the observability is not that great for very obvious reasons. First, it is very much complex, and accordingly, it requires quite, expensive infrastructure to monitor it. I believe that the cost of monitoring in per kilowatt is higher in distribution than in transmission system. So here, the potential of IoT and smart meters can be exploited. So IoT can be used, and apart from that, smart meters, these can be used in the state estimation very accurately. And basis on this, we can devise digital twin technology, which will be data driven. We're talking about the digital twin platform that we had a pilot. So it was able to perform the network calculations, grid state estimations, simulations, load flow analysis, short circuit calculations, and optimization Apart from that, we were also able to get the data in real time. So real-time monitoring, pseudo measured data for improved accuracy. On the right-hand side, you may see that there is a picture. So you can see that this is taken from the Venus Energy platform. So you can see that the Google map or the GIS map has been overlapped by the electrical network. So this gives you an enhanced visibility. All right. Now similarly, let us discuss one of the use cases of this. The objective here was to study the integration of solar rooftops specifically and see what will be the implications of the integration of the solar rooftops. So the there was a grid connectivity check feature in the Venus Energy platform where we can simulate solar, wind, biomass, and various other consumer loads and see what will be the response of the system. So there were 4 locations were modeled with network data, transformer data, details of the cable and load values. And with proper modeling, we tried to simulate the different loads. So first was, the loads as well as the generation. So first, let us take the scenario of a solar PV integration. The test site is Shivalik C block in New Delhi. So the capacity in the range of 10 kilowatt to 300 kilowatt at unity power factor was tested in steps. So you can see on the graph, upper graph on the right hand side that the node, there is a change in the node voltage as we keep on increasing the value of the solar rooftop. And the change is although not very much, there is only 3% change. On the other end, if you have a look at the percentage in the current, you see as we increase the value of the solar rooftop, the percentage change keeps on increasing and it becomes more than even 100% also. Apart from that, we also simulated some scenarios of the EV charging station integration. So we simulated level 2 of the charger. The load assumption was 176 kilowatt. It was a static load. And the graph is not here, but the result shows that it can be safely integrated at this particular site. Now concluding this, we see that the digital twin technology, it is going to have a lot of impact on the monitoring system. Improving data collection is very much required. Real-time data, SCADA, GIS is required, as well as consumer level data is also required. Currently, the smart meter, the penetration is not that good, and whatever the smart meters have been installed, they are currently being used only for the taking monthly readings. We are not utilizing the online or the real-time data, so that could be a suitable input to the digital twin technology. Smart meter infrastructure upgrades are required, deployment of smart meters, advanced meters, updating of the renewable energy penetration increasing, updating protection system schemes will be very much important. So concluding it, digital twin provides critical insights into grid performance and DR integration. Simulation findings highlight grid capability limits for solar PV and EV charging. These were the only 2 scenarios that we have studied, but there can be many more types of load as well as the generation which can be studied through this platform. And future focus on digital transformation will enhance grid resilience as well as the efficiency. And finally, I would like to acknowledge the support of Panitech Power, which were a part of the consortium, and BRPL, which allowed us all the resources for implementation of this pilot. Thank you very much. I'll be happy to take queries.
Thanks, Ajit, for a very insight of your presentation.
Thank you so much, sir.
Now, there is one slide where you mentioned that you have studied one case of Shivalik.
Yes.
Where you said that up to 250 kV, you don't need any change in their distribution system.
Yes.
Now, my question is that what is the DT capacity for which this 250 kilowatt level has been established? Because it must have been for the DT capacity.
Yes, DT capacity, yes.
So what was the capacity of a distribution transformer for which this 250 capacity?
Right. So DT capacity, I can recall, was 660 kVA.
660 kV.
Yes, yes. So it was coming out the capacity.
So what will happen that if it is more than 250 kV?
See what we have done, we have used...
Normally reverse flow takes place.
Yes, yes.
And there are issues of heating.
Yes, absolutely, absolutely.
Technically, that's my understanding.
Right.
Okay.
Yes.
Though I'm a non-technical man, but that's my understanding of the system that heating, but
you are
up to
absolutely
certain
correct.
level of percentage
Yes.
of DT level without much of a heating in the transformer, and you can have a
Yes.
reverse flow.
Reverse power flow, yes. Yes.
So are we saying that this is the limiting capacity?
Yes, yes. We are saying it.
So that is almost a 1/3 of a
1/3. Yes.
one
that's
third
correct.
of a DT capacity. You can have a reverse flow.
Yes. So I'll tell you
but if that power is getting consumed there, that means the total installed capacity can be even much higher.
Yes, it can be higher.
If
yes, that's
the
correct.
total PV capacity being generated in a DT network, in a closed loop,
right.
If that particular power is being consumed by the
consumers themselves,
up to 250 kV, it can do a backflow.
Yes.
This is my understanding.
Yes.
Am I right?
You're absolutely right. But I'll try to explain it from the perspective of a model from a mathematical standpoint. We have used Newton-Raphson power flow for analysis of this, and beyond a certain point, it does not shows the convergence. So it stops the convergence. So indicating that some of the limits of the maybe cables have been violated, they are becoming overheated. So that is why the Newton-Raphson is not converging. This is how, but actually you are very much correct. In case the generation gets consumed at the premises of the consumer itself, the penetration level could be higher.
Yeah, because I remember that when we were framing a regulation, especially on the net metering front,
yes,
the question is how much solar rooftop
could
distribution
yes.
licensee can be authorized to approve.
Approve, yes.
Okay. And what we had said is, I think it's 80% or 70%.
Yeah, it varies from DISCOM to DISCOM.
Up to that level, DT capacities, we had said
yes.
that it can be done.
It can be done. Yes.
Only that, and it can be more than the sanctioned load of an individual. But if the line connecting to his system needs to be upgraded, that cost,
yes, correct.
that SLD charges will have to be borne by the consumer who is installing
absolutely
it.
Right, absolutely.
So that system gets upgraded to cope with the increased generation and increased power flow back. So that the cable heating issue is resolved.
Yes, absolutely right.
So I think we were not very off the track.
No, you are absolutely
correct. We were
absolutely
framing those regulations. So any questions from the audience, please? No questions. Thank you very much.
Thank you so much, sir. Thank you to audience.
Thank you. Thank you. Next, we have Mr. Tushar Kantibag from TP Central Odisha Distribution Limited.
Good afternoon, jury, and good afternoon, my audience. The topics I am going to cover is evolution of substation automation system, as we know that the key task of the electrical grid is to provide connectivity between the generation and the consumer. The power system required configuration of the electrical network time to time to provide reliable power to the consumer and to maintain voltage and frequency of the grid to the predefined level. Typical changes in the system configuration include connection and disconnection of generation, transmission line, power transformer, shunt reactor, capacitor, etc. Now, electrical substation plays a pivotal role in this whole process to achieve reconfiguration, and the automation of the electrical substation was started long days back in 1950. The substation automation system is basically the artifact of software and hardware, which is used for controlling and monitoring of electrical system of the substation. Regarding the context, the history of substation automation system is closely linked with the development of RTU and the substation controller cum gateway. The early RTUs were telemetry application only that help collect data from different subsystems and send to the main control center room in the 1950s. And we find this application in power generation plant only. With the advancement of electronic system, the first electronic based RTU was introduced in 1960s and 70s. The first modern microprocessor based RTU was developed in mid-80s, that is 1985, and which can perform advanced PLC logic, can collect data through communication as well as I/O modules. However, communication protocol at that time mainly point-to-point, serial protocol, and many protocols were proprietary type. Relevance that substation automation system uses technology to monitor and control electrical system. It increases operation efficiency as substation system has evolved to the digital substation where we can have enhanced safety because CTPT are connected in the switched marshalling kiosk. So they have this operation engineers and operation personnel as well as maintenance personnel safety is enhanced. Reduce environmental footprint by using digital substation, reducing less copper cable, less number of panel. We can definitely reduce the size of the substation control room, which contribute to the less carbon footprint. The easier interface to IoT, which open the door for value-adding central application, big data analytics, and predictive maintenance. Improved reliability and flexible adaptation to the future requirement, easy incorporation of next generation sensor, integrated engineering, easy installation and commissioning. Now, just I'll tell you how evolution takes place. In the first generation, you can see that we are only hardware connection. We used to connect the RTU with number of I/O modules, and in order to do that, with the RTU panel, we have to introduce many marshalling panel to monitor the substation. And for monitoring in the substation level, we had only mimic board. That is again parallel wiring. The imported signal we used to connect with the mimic board. Second generation, if we go forward, what we'll see that RTU is capable to communicate not only collect data not only to the I/O modules, it is capable to communicate with the different devices like protection devices through communication. But communication that time was mainly point-to-point, and many of the OEM were coming with their proprietary protocol. And in that case, problem was that if one of the vendor is implemented the greenfield project, for addition of any base allowed to the another vendor is very difficult task. Now with the introduction of IEC 61850 from 2003 or 2004, that this problem is solved. Our station bus digitalization is complete. Station bus digitalization was started with generation 2, and in the third generation it is complete. Here you can see that RTU or station controller is taking data through the communication only. Now going forward, the fourth generation, we call it substation 4.0, where you will find that copper cable which is coming from the marshalling kiosks of the switch gear, which is replaced by a LAN, process LAN. As you know, when you are introducing any network, it is having an inherent delay. So here the challenge is huge to provide that, because especially the protection function, where we used to get the CTPT directly to the protection device. Now instead of that, the data is coming to the network. So all these challenges are overcome by developing IEC 61850, the 9DS2 protocol. For time synchronization, it is also very critical. In station bus, we are using SNTP, which can give you millisecond range accuracy, where you can find, in this case, PTP will get microsecond accuracy, which will fulfill our requirement. Now here you can see that in the bay level, we are using huge number of protection and control devices. Now, definitely it will come in mind that this is one of the things which is contributing big cost to the digital substation 4.0. Not only that, the Ethernet switches we are using, it is compliant to IEC 61850 as well as PTP compliant, which makes this very expensive items. So this part you can say, the 5th generation we are talking, this is not much implemented, but many OEM are working on it and they are implementing different POC and very successful POC that protection and control device is virtualized. We are transferring this to some number of servers. Now, how many servers will be there? It depends on how this software is designed and developed, and if how big the substation is, what is the data volume accordingly. In this case, you can see if we can use one redundant server, the server has to be IEC 61850-3 compliant, which is required for substation application. With that, we can fulfill the complete requirement of the substation, all the CNP server, control and protection server, as well as this gateway function can be accommodated with that depending on the substation size and the data size and the criticality, and this would be a big advantage for us. Now, use cases, as you know that use cases could be a different type of substation as we are talking from the 1st generation to the 5th generation, but in the substation level, distribution level, digital substation implementation is not so viable, still it is in the costlier. So 3rd generation, that is up to station bus automation is being implemented in distribution in India across. In TP schedule, we have 385 PSS, wherein 350 substation we have automated. The problem was that these are all conventional substation. There was no option of centralized monitoring. Okay. Now, the solution we have provided, RTU-based automation, which integrate BCPU, relays, DC system, fire detection system, TMU, NIFPS, and MFM for real-time data monitoring integration with the control center SCADA. Benefit, we are having remote control and real-time monitoring of the PSS, unmanning of PSS, cost saving in operation, because earlier we need to deploy operation engineer in all the 385 substation, you know, very costly for us. That we have made many substation unmanned, gradually we will make it 100%, and these operation engineers are being utilized for other purposes. Faster restoration, improvement in AT&C losses, improvement in reliability indices, SID, SIP, IP, and remote maintenance and configuration, and customer delight. Now, key takeaways regarding this. Over the experience and the VPN substation automation system we have implemented, PRP HSR is one of the protocol is being for the digital substation. Now, PRP as we are using with the number of Ethernet switch is very high in that case, but if we go ahead with the HSR application, HSR protocol, that number of switches we can reduce a lot. Now, DRPC. Now, with this the RTU or the substation controller which we are using, that is using for controlling, monitoring or data and sending data to the control center. But if we embed the function of DR data, disturbance recorder data, because collection and analysis of the disturbance recorder data from the control center level is very essential nowadays. So with the same application, we need to embed the DRDC data concentrator option with the RTU and the station controller. The SCADA communication, you know, for a big area in TPCODL part we are talking, it is having 29,000 square kilometer area. In order to implement fiber optics network infrastructure for this, it is quite expensive. Now, what we tested, use current mobile network system. Then with that, we can achieve reliable communication. We are having 99.9% reliability with the LTE modem, and the recurring cost also very cheap. PTP time server, as it is very crucial for the digital substation. The PTP is another costly one, but you need to have redundant PTP server, but if any of the, if you go for a single PTP server, if fails, your complete protection will be jeopardized and you cannot use the substation. And only overhead and earthfall protection will be available, no other protection will be available. Networking, that as we can see that in the process bar level, we are dealing with the protection data. So in that implementation should be taken care, fiber optic termination, etc. All this has to be very good, otherwise failure of this will result in failure of the complete substation. Cyber security is very much required. It has become integral part of the substation automation system when we are going ahead with digital substation. And all the requirement of cyber security norms and conditions as guided by CA as well as all other standards should be followed. Like IEC 62351, IEC 62443, IEEE 1686. Now, where we are heading to? Gradual improvement is there. Now, what will be the development? What will be the end to this substation automation system? That you might have many, but I have some view that switchgear could be equipped with all necessary sensor and actuator, that too with one wireless communication port, which could support the bandwidth requirement for the communication with the upper level devices. In the future, smart switchgear with wireless communication capability could reduce the cost of substation communication infrastructure, and at the same time, commissioning and maintenance effort will be reduced to a great extent. That's all from my side.
Thank you, Tushar, for a nice presentation on your substation automation, and especially with the widespread area which the data power center research is having. Integration of data using RTU and mobile networks. I think that's what we learned from you. And it's a cost-effective way of handling things rather than automating everything in one go. So it's really a great job in terms of nice presentation. So any questions from the audience, please? No questions. Thank you very much.
Thank you, sir.
Thank you. Next we have Ms. Purnima Gupta from CEA.
How do you operate this? You have to just press it. This one?
Yeah, upper one. Up or down, right? Down is for back, up is for the...
Acha. Namaste. Good day to all of you. Framework for Indian carbon markets. Can you hear me? Can you just help me with this? Which way do I press? The next one.
Go back. Forward or backward?
Okay. आप एक सेकंड खड़े हो जाओ, हाँ? एक सेकंड के लिए. Framework for Indian carbon markets. It was at COP29 in November 2024 that the United Nations finalized a global carbon trading deal, which was in accordance with the Paris Agreement of 2015. So from 2015 to 2024, about 9 years it took to arrive at this decision. So the negotiations had been going on from 2015. However, the subject was so complicated that you could not arrive at a decision. So it was only at COP29 in November 2024 that we could agree on a compliance mechanism. That is, we agreed, the United Nations agreed on a regulated carbon markets. That is, the governments will take control of the carbon markets, and that was to be worked upon. So it was a very historical moment because it took 9 years, which is a fairly long time, to arrive at a carbon market. However, voluntary carbon markets have been existing for more than 20 years. It was labeled as the Clean Development Mechanism, and it was started long ago as part of the Kyoto Protocol, which, however, did not take off for whatever the reasons. Some of you may already know about that. The evolution of this framework for Indian carbon market is given in the paper presented for ISUW. And as we have to be very brief, I would like to say that my paper has gone into the issues of sustainable practices. Sustainable development goals are the guiding blocks, as we know. For all the actions related to sustainability, the goals have been specified by the United Nations, and sustainable business practices which are based on mitigation of greenhouse gases and adaptation that is suggested. It is very relevant to understand the various challenges and opportunities that are there in this process of energy transition, which is highly relevant for the carbon market, because carbon markets, the whole process was started with the purpose of reducing the greenhouse gases, and that is also a spillover effect of energy transition. So it is highly linked. All of it is very linked, and we have to understand that. And the whole thing is in the domain of physical environmental factors, that is, the anthropogenic emissions caused by human beings. They are bringing about the greenhouse gases which are going out of control, and that falls within the realm of the environment, the physical environment of our planet. And the markets, the commercial markets which we are all familiar with, do not take into account these factors. That is, the negative impact of the climate change flowing from excessive greenhouse gases is not internalized by the commercial markets. And hence, we have to internalize it through other means. Government has a whole lot of policy interventions, and one can understand that carbon markets are also a policy intervention in a larger frame of things. And that is how we have to look at the carbon markets. So the Indian carbon markets are a structured approach to deal with this problem of climate change. And the Indian government is also working very earnestly towards a regulated carbon market. We have taken it upon ourselves in the government of India to work out the modalities. And it is a work in progress. It will be by next year that we will actually be there. But the work is going on. We have started working on it. The Bureau of Energy Efficiency is the administrator, and the Central Electricity Regulatory Commission is the regulator. Obviously, the Ministry of Environment, the Ministry of Power are closely working on this, because Bureau of Energy Efficiency falls within the Power Ministry. And similarly, the CERC is also linked to the Ministry of Power, and the subject being of environmental nature, the Ministry of Environment is also involved with it. The rules are notified already. There are two important schemes, the Green Credit Program implementation and the Carbon Credit Trading Scheme. These two schemes are going to be the method, you can say the vehicle through which you are going to proceed further along this journey. It's a long journey. It's a very long journey. Any industry will have targets for emission reduction, and an enterprise which is not able to reach those targets will have to purchase the carbon credit certificates. So in some sense, the carbon credit certificates are a reflection of the fact that you are not able to meet the targets, and you are paying a penalty through the purchase of the certificate. And who will give, supposing I am going much beyond my targets, then I am a gainer. I will get money for that. So I'm a gainer, I get money. It's like a bank, you know. So I get money, I get like an interest income, because I am adding to the revenue of that bank, which is a reduction in emissions through my sustainable practices, obviously. So there are a lot of global challenges. India is very well aware that it is not just, within the country, because climate change, as we know, it's a global process. Greenhouse gases, they don't stay in one nation. They don't observe the political boundaries. They go much beyond that. So it is a global problem. Everybody knows that. And that is why the United Nations had to come in and, do their bit on it. So it is a global challenge. And India has to meet that challenge by reaching 500 gigawatts of renewable energy by 2030. Obviously, energy transition is the key word here. And geopolitical tensions have made this whole process very complicated because of the supply chain challenges, as we know. And that is linked to a lot of geopolitical tensions, a lot of wars going on. So that is linked to the energy market, the supply of gas, and linked to the photovoltaic cells, because we need that for our solar energy. We are importing a lot from China, maybe Korea also. So the geopolitical tensions are adding to the challenges, and India has to look at the demand side also. The economic survey has very clearly specified that. The life mission, which advocates a simple lifestyle, frugal life, we have to, all of us have to be conscious of the environment, save our planet Earth. So we have to be all conscious about reusing and reducing our energy emissions personally to the extent we can. So everybody takes care of their carbon footprint, then we are slowly, going towards energy transition. And all of us here are very well aware of the problem. I don't have to go into detail. And there is a global challenge which India is facing, which is the cross-border adjustment mechanism. So this mechanism says that European Union will impose a carbon tax on all the things that we are exporting to them. So that means they are very much concerned about the carbon footprint of the industrial processes in India. You understand what I'm trying to say? So, and the revenue that is going to be moving to Europe from India is going to help them in their own energy transition. That's the upshot of the whole thing. But why should they be concerned about our greening our industry? I think our industry has to be conscious of that. And we have to do our greening ourselves in a real sense, not just कहने के लिए नहीं सिर्फ. We have to be conscious, and industry is conscious, but they have to do more. Because you don't want somebody else कि डंडा वहाँ से पड़े, अपने आप ही आप कर सकते हैं. Why do you want them to, show a stick to us? Because in that process, India will be losing a lot of its secrets. I mean, the Indian industry, which is not very competitive. You don't want to lose your competitive strength because of a thing like carbon tax being imposed by the European Union. So you better wake up, and government is already working in its own way, working in every possible way to help. Government is helping in every way to encourage them through incentives, like the greening of the steel manufacturing in India already. Government is going to put in such a big energy fund, which will increase the greening from about 7% at present to about 43%, which is, because that is the industry which is going to feel the impact of this carbon tax, which is expected from January 1, 2026. However, the negotiations are continuing between India and the European Union at the government level, obviously, to make this a little more supportive. So what government has said is that at least the micro enterprises, the small enterprises, please spare them. You cannot already they are subject to so much of competition, and if you put more taxes on them, then where will India be in its export profile, How are we going to encourage our exports to European Union? And they need these goods, they need it. That is why the export process takes place, isn't it? So that negotiation is going on. So what I have suggested in my presentation and in my paper, a detailed paper given to ISUW, that we should support the Indian industry. However, Indian industry must also be conscious of the Sustainable Development Goals and must imbibe more practices, even if it is difficult, because that is the way to proceed in the long term for the planet Earth to be saved. That is the only way. If we are not conscious now, then when are we going to be conscious? The world has been affected. There are heat waves. There are so many floods. They were there before, but the intensity has increased. And as he said, the need of the hour is to become more aware, to do more for our planet Earth. And that was the motivation which made me write on it. Because I sincerely feel that we have to do more to save our planet Earth. Thank you very much. Thank you for listening to me.
Thank you, Ms. Purna.
Thank you.
It's a really nice presentation.
Thank you.
I think the concept of carbon credit was almost a quarter of a century old, I think. 20, 25 years
long
old.
back.
First being introduced.
Yes.
And I remember many of the Indian companies did apply, but they
Nothing
never succeeded.
Came. Yes,
they
that was in the voluntary system, was voluntary.
But now with the thrust of the government on more and more of a decarbonization and environment friendly and stringent targets on, you see, non-conventional sources of energy, which is non-polluting, and probably we'll be able to do a really major job, and especially the kind of rules being framed and already published and put into position, and CRC working on it for its implementation. This will really go a long way. The only thing which sometimes comes to my mind is that when we talk of a target, for example, 500 gigawatt of installed capacity, now whether that matters or whether that is the gigawatt hour, what will we generate? Because carbon footprint will not increase by the capacity installed, but what actually we generate. So probably our target should be on more CIF based, that higher the CIF, probably with the lesser capacity also.
CIF number?
That is a cumulative generation over a year.
Over a year.
So for example, the solar power today we have 17% or 90% of plant. That's the way we call it plant load factor for a power station. It is called a CIF for the non-conventional kind of system. So if we can, instead of 17%, if we can do 20%, 25%, probably a lower gigawatt installed capacity will achieve the same target of reducing the carbon footprint. Then, so probably we'll have to work hand in hand. One is the capacity addition, and one is a technological upgradation for improving our total generation from such kind of units. So that the overall carbon footprint reduction, that is a share of generation from non-conventional to the conventional, is changing at a much higher pace than the installed capacity.
You also need a greater integration
and
of
greater
the
integration
of the solar into the national grid.
And
also.
our regulations even need to broaden its view. Now, for example, even parapet wall-based wind power plants are going to come in.
I see. Where are they coming?
In India itself.
In India.
Technology has been developed, where even on your any terrace, you can put a small windmills.
Oh, that's very interesting.
Because when we were interacting, when we framed our first net metering regulations in 2015, we had foreseen this.
I see. Okay.
So we did not say net metering regulations for rooftop solar PV.
But it's very expensive. Solar PV
That's
is
it.
very
Question
expensive.
is the regulatory framework has to enable. Cost is a secondary issue.
Right.
So that time we had said that any renewable system you put in your net metering system will get the same treatment what the solar power PV. We said that our system should not be even to a rooftop. Because there are many countries where there is a vertical growth of the cities. And the solar power is being generated even on the window panes and the wall paints. Now if you restrict it to solar rooftop, then you are not allowing the other technologies to come in and to get a best benefit of what resource is available with us. So that time we had I remember that when we were developing a regulation, we said anywhere in consumer premises, any kind of a non-conventional system will be eligible for net metering. Okay. And that regulation was subsequently
That
adopted.
was CERC.
DRC.
Sorry, Delhi
DRC.
Electricity.
And then that regulation was subsequently adopted by Brazil.
I see.
They took it cue from that. So that is where we need to work on, to look at what other countries are doing. What, for example, even many countries are doing that road-based solar power generation, where there are things.
Yes.
And even at that time, we had suggested to this RDSO that the naval ships which are put in the sea, you have a big airstrips on that.
Right.
Even that could be painted with the solar power generation, and you can reduce your diesel consumption, and that can work toward decarbonization of a system. And they are working on it. So something of that kind, we have to put at disruptive technologies to really enhance our, and that may earn carbon credit as well, that is an incentive. But the main is that for the human being and as a global commitment, what else we can do for decarbonization. So carbon market is definitely going to give a major thrust, and the technological developments and innovative regulations, they will be complementing each other to support this. So thank you very much. Any questions from the audience, please? Yeah, please.
I was looking forward. Interesting presentation. So you did cover CBAM and what steps should be taken. One question that I have is, looking at an Indian context, we are still a more coal-dependent power generation industry, although there is capacity additions of renewable. Still, if we see overall consumption of coal, power industry leads there. That being said, when we have compliance market kicking in, there can be a rise of purchasing carbon credit certificates, which will in effect increase the cost of carbon credits. So compared to other countries, I think Indian power industry might end up paying a higher price of carbon credit. So what is your recommendation in that area? Like what India should do in terms of incentivizing the cost or reducing the cost of carbon credits?
Well, you are asking a question which is like called predictive analytics. I need a model for that really, So I'll have to take the independent variable and all the dependent variables, because the dependent variables are many here. So, but I will put it in a very simple, commonsensical answer to this whole question, which is that I, as a proponent of the whole system, the process of developing and evolving this market, I would say the higher the credits price, the better it is, because then the penalty is more. So you will try to reduce your emissions. If something is more expensive in the market, like I'm guilty of producing more emissions, and I have to go and pay for that excessive emission. I have to buy a carbon credit, isn't it? So when it becomes more expensive, I'm being penalized more. So I would say, please, I will tell my industry, ki bhai kam karo, because I'm not able to afford that kind of payment. It's too much of a penalty for me. So in fact, the harsher the penalty, I'm looking at it from the point of view of the stick, not the carrot. Harsher the penalty, the better it is for the system. Then only people will understand. अगर सस्ते में मिलेगी कोई चीज़, तो आप तो उसको emissions बढ़ाते जाएंगे क्या? जैसे lawyers हैं, अभी 200 रुपए की फीस देनी है, तो ठीक है, क्या फ़र्क पड़ता है? आज भी ट्रैफिक को वायलेट कर लो, कल भी कर लो, और वो 2 लाख की अगर होगी, रेड लाइट को आपको अलर्ट करते हैं कि 2 लाख है. If you are going to, run over a red light, you will be 20 times more careful. So, I am a proponent of planet Earth, frankly, and that is the motivation, as I said, why I came. So, industry also needs a stick. It's not just the carrot, Government is giving many incentives.
I look at it like industry getting a stick, passing on to the customers. Probably.
That is going to be worse, isn't it? It's not good for the industry. If you pass it on, तुम्हारी product कौन खरीदेगा? If you make the product more expensive, then you're hit double. If you don't want to sell your product, and if you don't want to pay the penalty, then you might as well be out of business. Why are you in business in the first place? So the whole idea of this whole presentation was to bring on board the issues which are there in the field of environment, and it's a very complicated subject. This is just one step, in that whole journey. It's a very long journey, and for our next generations, we have to keep a planet, where they can breathe properly, where they get good water, good quality air. We are suffering. We are suffering and getting old in the process. Let them not suffer so much. If intelligent people, elite, like everybody coming for such conferences, if we are not able to do our bit, then who will? Who will? So I hope we are positively oriented, and that was the purpose, that industry should look at it as a citizen of the whole planet, not just as a person making profits all the time. That is okay. But don't make profits at the expense of, polluting too much. The polluter has to pay, and he or she must pay. If not now, then sometime they have to pay. Thank you very much. Anything else?
You see, thermal generation you cannot do away with. Let's understand that. For the stability of the grid and the system. Because all other kinds of generations are fluctuating.
You buy good quality coal, you buy less sulfur.
The other issues which can address your decarbonization issues, one is carbon capturing. And then, for example, recently a trial has been done extracting methanol from flue gas. Vindhyachal pilot project has been done by NTPC very successfully, which can be refired back to the system. Okay. So, which is going to reduce the carbon footprint while giving you more generation.
Also good quality coal.
Good quality coal is a
with
basic
less
requirement.
emissions.
And then thirdly is upgrading the use of technology. You see, earlier we used to have a subcritical boiler, then came supercritical, and now we are going for ultra supercritical. So even there is a technological development. From the same heat value, you are able to generate more units. So it's a, you see, they will all go hand in hand. Straightway saying that there will be no thermal generation. Even if Government of India wants to say that, okay, there will be no thermal generation, question is what you will do with so many lakhs of people employed in the coal industry.
Absolutely.
There will be massacre.
You cannot, and you need
so
the energy.
There is a
you need
balance
the energy.
between the social and the environmental requirement. You can't be just having only one kind of a thinking.
And this is a slow.
It's not possible. And then what is the per capita greenhouse generated by India versus anywhere in the world? We are at a much, much lower level. It's only being made an issue. We are only consuming how much? What is my per capita power consumption? It is, I think, 1/10 or 1/15 of the many of the developed countries, and maybe average of 1/4 of the world average or something like that. So that is where we stand. So our carbon footprint is much lower than many others.
Absolutely.
So let's not talk of that, but definitely we have to work towards environment-friendly generation and take benefit of carbon credit and develop a carbon market.
Right.
Take best use of it, and I think that's...
Because our energy demands, you have Viksit Bharat Vision 2047. The energy is the basic engine for the nation. Your demand is going to increase 3 to 4 times, it is projected. And the country is expected to grow by 8% in real terms. So for that 8% growth, where are you going to get the energy? You will not get from renewables. You need all the sources, including coal. You cannot do without it. We all know that, isn't it?
And you cannot cover the entire nation by PV solar cells. Then you need the food also. Then where you will grow your agricultural growth? And you can't cover every land for that. So it has to go, that's what I said. We'll also have to look for vertical solar generation rather than horizontal solar generation. Unless we look at that and work towards it, we will be always lagging behind in our targets. Because today that is the target for a particular year. But year on year these targets will go on increasing. There is no end. So we'll have to work on a different framework to upgrade our systems.
Because environment and development, they have to go together. You cannot say one at the expense of other. It has to be together. And you keep balancing. So that is what everybody wants to do. You have to keep balancing the two objectives. So there is a cost. Either way, there is a cost.
There is one question.
Ji.
No? No question, just a comment? Please. Please.
No, I think balancing is the key word. I think that's fantastically said, and I do agree. It will be a mix of multiple technologies to supply the power for the country. And, you know, on one end, when we increase solar, we are going to hit the manufacturing side of sustainability, which is how to recycle all those panels after its life cycle 20 years, and how do we provide that additional materials which can help us into a recycle economy. Until that is figured out, even with vertical solar, we are going to hit, you know, SMRs is one option, but then thorium versus NATO agreement will become another. So, yeah, I think it is an interesting journey. In our lifetime, we can see for next 30 years what's going to happen with energy transition.
Even fusion is a coming thing.
But the TRL is low right now.
No, it's for the nuclear.
The technology readiness level is low, and for fusion to mature, it will take another 20 years.
At least 2-3 decades to really mature.
Right.
Thank you, ma'am.
Thank you, Ji. Thank you. Thank you.
Thank you, ma'am. We have Ms. Maitri Karthik from RTI International.
Hi, good afternoon, everyone. So my session today is going to involve, my topic for today is on enhancing regional energy cooperation in South Asia, lessons from various successful stories across the globe, and the need for a unified regulatory framework. So how I plan to cover this is, I will be first giving the introduction of the South Asia region and the need for regional energy cooperation in terms of energy demand, energy access. Then I would proceed on to the case studies on which I have worked on. And finally, I'll be giving some takeaways and recommendations which we can have for regional energy cooperation within the South Asia region. The first slide talks about the renewable energy potential. So South Asia region holds significant renewable energy potential, especially there is about 350 gigawatt of hydropower potential within the region, more than 1,000 gigawatt for solar, and more than 900 gigawatt for wind. So cross-border collaboration could enable the countries to harness such resources more effectively. Then the energy access again remains a very critical challenge within the region, and the demand is going to triple by 2040, as ma'am said earlier, and this would require large-scale investments in infrastructure and renewable energy. So, but when it comes to infrastructure as well, there are a number of challenges associated with it in terms of fragmented infrastructure connections and grid interconnections and aging systems. So this actually complicates the cross-border energy trade. So the energy sector in the South Asia region is facing a huge energy demand and supply challenge. So this presentation would explore the current state of the regional energy cooperation and draw lessons from successful energy trade that's happening across the globe. Now these are some of the statistics which I'd come across. The cross-border electricity state currently in South Asia region is about 5,700 megawatts, whereas the hydropower potential is around 350 gigawatt. India alone is contributing to about 42% of it, and 10% of it comes from Bhutan. When we talk about in terawatt hours, the energy trade that's happening in South Asia, so for 2023-24, it was around 24 billion units. But there are a number of significant cross-border lines which are under planning or construction stage, such as the 765 kilovolt Katihar Parbatipur Bornagar connection. Then there is the 400 kilovolt Arun 3 interconnection that's currently happening. Then the India-Sri Lanka interconnection, which is currently going to happen. So these decisions are taken up on a case-by-case study only, except for the 400 kilovolt Dalkebar Muzaffarpur line and the dedicated Goda transmission interconnection, which was basically the conventional government-owned model, has not been used for this, and it's basically going by the JV mechanism. So some of the key findings while I was doing research I came up with regarding the business model for the cross-border interconnections were across the globe. On the left-hand side, these are the interconnections that's basically taken up. The public ownership, which is most common, and it is being undertaken globally, in which it's basically the government-owned entity. Then we have the independent power transmission, or the BOOT model, which is the build, own, operate, transfer model. And in this, sometimes the entity may also be JV with some other government organization. Then we have the merchant power transmission. In this, the line is developed without any long-term assurance, and it's basically on short-term market based. Then we have the financial ownership model. In this, the line would be developed, constructed, and operated by state-owned transmission operator. This has been there in Europe, such as the Denmark-Germany interconnection. Then there is this dedicated transmission line. This is for evacuation from a power plant, typically operated by entity other than owning the plant as well. So cost would be on the basis of the power purchase agreement. So most of the predominant models based on the regional practices on business and ownership models for cross-border electricity trade, for South Asia region, if we see that it's basically the government or the public ownership model with dedicated transmission line. But there are some few exceptions, such as the 115 kilovolt HVAC Cambodia-Thailand interconnection. Then again, when we go for Africa region, so it's mostly the government public ownership model. But there is other, such as the 220 kV HVAC Zambia DRC interconnector line and the Mozambique transmission Motraco company dedicated line. So these are some of the exceptions. Then in Europe, all of the models which were discussed earlier are present. Similarly, for Central and South America, predominantly the government-based ownership model is being there along with the JV model. But there are some exceptions, such as the Itaipu transmission line, which is one of the exceptions there. So these are the case studies of cross-border transmission line which I had undertaken. So if we see here, so for the Cambodia-Thailand interconnection, the underlying arrangement is it is PPA based. It's a single entity model. So in this way, for the Motraco line, it is again an HVAC interconnection with wheeling arrangement as well as the PPA agreement mode available in this. One of the classic feature for this would be the Mozal Aluminium, which is there as an anchor customer for this model. Then if we go for the GCC interconnection project, it is a multilateral agreement project with the government utility and IPTC in JV consortium for this. Again, the NIMO link for Australia model, this model is an HVDC model. In this, the investment is is as a JV of government utilities. And one of the special feature for this would be the cap and floor tariff regimes as well as the auctions that is happening here. So when we see that for regional energy cooperation within South Asia, so there are a number of challenges pertaining to it. The primary and the most important one is the political barrier. So politically, there are a number of tensions happening. Each country has got their own systems in function. So a complex political relationship and tensions among the countries, they are proving to be a hindrance for regional energy cooperation within the region. Then another would be the regulatory frameworks that is currently prevailing in each of these countries. Most of the countries are on a different level of regulatory frameworks, and this creates quite a challenging scenario as well. Then the infrastructure within each of these countries are at a laggard. Although the energy is improving, I mean, we are having high tensions of more than 300 kV, 500 kV, 765 kV happening, but the infrastructure is lagging there. So that's again a challenge there. Then we have the investment constraints. So investments as required for improving the infrastructure within, transmission infrastructure within this region is currently not available. So these are some of the challenges pertaining to regional energy cooperation. But why exactly do we need regional unified regulatory framework? So when we talk about unified regulatory framework, it offers a number of benefits for South Asia region. For example, the electricity tariffs can be aligned when we have a unified regulatory framework. Then we can have a common grid code, environmental standards, and this would create a very common regulatory harmonic prevalent in that entire region. Then we can have, this can be helpful to develop cross-border transmission infrastructure and also improve the grid connectivity within the region so that the energy access and the demand supply problems can be mitigated. Then this can also help to establish common standards for renewable energy technologies. Then pricing is one of the very important thing when we talk about a unified regulatory framework. So a standardized electricity pricing across the region would help to improve, would help to have a reliable energy security within the region. Some of the key takeaways from the case studies that I had worked on were there should be a structuring of line ownership across the borders. This can be adopted maybe beyond the border of two countries which are operating within the region. Then there should be more PPP-based business model that can be introduced within the region. Then intergovernmental and inter-utility MOUs would be actually relevant for those countries which are working other than India as well within the South Asia region. So in the absence of a firm PPA for full capacity between the governments and intergovernment or internet utility MOUs, anchor consumers can be roped in who can be there for long-term trading aspect, looking after long-term investment for the trading, cross-border electricity trade within the South Asia region. Then transmission tariff models. So ultimately it requires that there should be an annual payment within when two countries are basically trading, so there should be the permanence of an annual payment. So this can be held through a common transmission tariff model that can be prevalent there. Then for cost and revenue sharing, there should be a uniform infrastructure-based and benefit-based cost and revenue sharing within the countries, which would be really helpful. Then liberal access to regional power market would ensure that small quantum of untied capacities can also be utilized through market-based options. And then finally, there should be a regional financing of cross-border transmission infrastructure so that all the burden do not fall on a particular country within the region. So these are some of the key takeaways. And going forward, enhancing the regional energy cooperation is the requirement. Unified regulatory framework would help to unlock the complete potential of regional energy integration. So South Asia must actually align the regulatory frameworks, infrastructure and investments in order to create a very sustainable, energy secure environment within the region. If it is implemented successfully, these would help to foster economic growth within the region. So that's it about it. Thank you.
Thank you, Ms. Mehta, for a nice presentation. You see, cross-border trading is already taking place almost across the globe in many locations. And now with the concept of one sun, one world, one grid, this will expand much faster than this. So unified regulations will become a necessity for the whole system to operate.
Yes.
And it's not only the uniform regulatory framework, even the infrastructure interlinking requirement and interconnection point, voltage balances, because the transmission system in one country may be different than a different voltage, and the other country may be different voltage.
Definitely.
So those kind of matches. And when you are trading, especially, you are skipping a country in between and you are giving to the third country.
Yeah.
Then losses en route in that country, or any pilferage en route in that country, how you are going to account for. So there are many issues which will have to be addressed.
Yes.
And the forex exchange rate fluctuations.
Definitely.
Also, it's going to be a complex exercise, but a very interesting subject which needs really an insight and really working hard onto it.
Yes. So in this regard, I'll just give a short example. So right now this Arun 3 plant is coming up. So it's actually between three countries, Bangladesh, India and Nepal. So Nepal wants to export to Bangladesh via India. So there is a small pathway in if they can come through Uttar Pradesh. So that can actually reduce the infrastructure
because the distance of transmission reduces.
But it again creates energy security concerns for India as well. So there
if UP needs power, they will tap it there.
Definitely.
It will never reach Bangladesh.
So
there are many issues.
There
are many issues. So energy security, all kind of things will come, but really it will need a very high end of negotiation, discussion, and developing the end. Putting safeguards into the system.
So an appropriate model is required for that, which actually combines all these agenda, all these requirements.
Normally, power will not move from Nepal to Bangladesh. It will go by displacement. Frankly speaking, no power will go from Nepal directly to Bangladesh.
Correct.
It will put at some contact point in one state. They will start drawing from there, and their own power incoming will go to the next state. So it is always
There's a lot of challenge of reactive power compensation. All those things are also quite prevalent in those conditions. So yes, a lot of challenges.
Very interesting subject, and really it's a need, emerging need. And it has to be, if we start working on it, it will still take some time.
It will take a lot of time.
Even put a first draft into position and then going on amending it.
The demand is actually increasing threefold, but the supply is not there currently.
Supply is not there. So these regulations, maturity itself will take a time from development to maturity. So any questions, please?
In this case, when we are talking about energy from Nepal to Bangladesh, it has to go through India. But with India, we have HVDC connectivity. Through that only we exchange power, because directly grid connectivity is definitely a concern for us.
So HVDC connection is already prevalent there. So right now there is this Arun 3 hydropower coming up. So they have established a link, but the power flow will happen only from this year. So they did that for 15 days. They tested that site, but ultimately it will start happening from 2025 only. It's still not there. So 6 months they have taken up to maybe observe and all, but after that only it will start happening.
Yeah.
They might be looking for power transfer to the chicken neck because it has to
Yes,
cover very
yes,
less distance.
yes. So
They
there are a
will
lot
pay
of problems there.
They will pay less to India.
Yes.
I think that will be in their mind.
Yeah, so they want to, basically, they were suggesting in one of the conferences that from India, there is one place in Uttar Pradesh. So they want to dig a hole and go through underground in order to minimize the losses. But the Indian government has to see if that is possible, because our security, our region's security would also be, the concerns would be there. So these are some of the aspects that we are still working on. It's not yet complete, so it's still in the negotiation stages.
Okay. But something better will come up.
Yeah.
The Indian grid is already connected to Bangladesh, and the power is flowing between India and Bangladesh.
Yes.
So only that much volume will get displaced.
Yes.
I think it is Odisha or somewhere it's connected, or maybe West Bengal.
No, it is in Bheramara, that is on
Behrampur,
HVDC connectivity is there.
yes,
And I
Behrampur,
think from
Behramara.
Tripura directly grid connectivity is there.
It is HVDC, yeah, HVDC, double HVDC connections there.
So I think power reaching there is not an issue.
Yeah.
It's energy security and commercial transactions and all those things. Are
Grid security and grid stability.
Those are major. Yeah. Yes, please.
The recent tensions in Bangladesh, the political tension, thank you. The recent political tensions in Bangladesh, did it affect the stability of the supply of electricity?
See, their demand is actually increasing now because of this political tension. But it's not going, it is going to affect the stability, but again, it is all intergovernmental talks. So we cannot say here for sure, but yes, it's going to affect the stability and reliability of the power security as well. So energy security and energy reliability, these are the twin challenges.
Yeah, in a situation of a problem, then who will bear the cost? Supposing there is some destruction, which is possible.
Yeah.
If there is a war or if there is a political tension, you know, some damage is going to be there. Who will bear the cost of that? Will it
So
be
ma'am,
India or
it's
Bangladesh?
basically contractual agreement based. So when an agreement is drafted, in that it's already given. So if it is JV, so then it will be like 50-50 would be done by both the countries. But if it's a tripartite agreement which is coming up right now, so those laws would be different. So it won't be entirely a JV based agreement. There will be some other agreement. There would be an anchor customer there involved who will look after the investment of it, because no one particular country would want to contribute entirely for all the problems.
Naturally. So that customer is Indian or Bangladeshi, or third party means third country?
No. That would be decided. Again, it's an agreement-based thing, so that would be decided. If it is going to be in India, so in India it will be one of the power generation company they would be looking after. So that is again in talks only. So we don't have a clear picture of it as of now.
But as of now, this more than many months, you know, this is happening. There is no damage to the system. The infrastructure?
Not as yet.
Not as yet. Everything is going smoothly.
We know that we have a power plant in Bangladesh.
Okay, good.
As an NTPC.
Good to know that. Good to know that. Okay,
a lot of
thank
people
you.
are working there, so it's nothing of that kind. Yeah. Okay, thank you very much.
Thank you.
Thank you, Ms. Maitri. We have now Mr. Gufran Basit from Siemens Technology and Services.
Hello everyone, I know it's a time for lunch. I'll try to keep as short as possible.
We are still within our prescribed time.
Okay.
Revised prescribed time.
Okay, good afternoon to everyone. My name is Gufran Basit and I'm working with Siemens. I would like to express my thanks to ISGF for providing me this platform, and it's a consecutive third year when I'm presenting my paper and I'm happy to share. Let's start. Before starting our topic, I just want to set up a context. Today, in the tapestry of urban transformation, we often overlook the supportive functions that enhance primary operation across various sectors. Yes, I'm talking about the ancillary services. Ancillary services play a vital role in a smart energy system as a specialized functions that extend beyond the generation and transmission of power. So let's start with my topic, which is regulatory framework for ancillary services in involving smart energy system. I'll talk about its challenges and strategic solution. So, as of now, we are living in the era of prosumer, as we know. So, in the swift evolution of smart energy system, the ancillary services are essentially energy solutions that not only safeguard grid stability, reliability, but also ensure that the seamless power will continue in any sort of a dynamic supply or demand fluctuation. And for that, it's definitely required a demand, it definitely demand a strong regulatory framework. And the building blocks of those regulatory framework could be around grid stability, as it mentioned over here, a renewable integration, a regulatory challenges, and what are the policy solutions. So in the picture, you can see easily the grid stability, what does it mean by? It could be a positive balancing, it could be a negative balancing. So when I say positive balancing, it means a too much energy consumption. When I say negative balancing, it will be a too much power generation. So ancillary service are mainly helps to balance the grid. So this is one of the primary, you can say, a function for these services. So let's talk about what are the role of ancillary services in a smart energy systems. As we mentioned already, it helps to make a reliable and stability of a grid. We can categorize ancillary services in typically three types of. One is F-case, N-case, and SRS. I have categorized in mainly two ways. One is that what are the key ancillary services and what are the emerging ancillary services. So when I say a key type of ancillary services, which are nothing but a combination of F-case, which is a frequency regulation, what does it mean? It balances a supply and a demand in a real time. A voltage control ancillary services, which helps to consistent voltage level across the grid. Yeah, there are few more. One is reserve ancillary services and a black start capability services. These helps in sort of sudden demand or a generation fluctuation, or we need a restoring of a power in sort of any total or a partial blackout. So these are the main key ancillary services which we have currently. We can also think about some sort of main emerging ancillary services, which could be a cyber security as a services, as we are living in an era which we need to rescue our grid from a cyber threats. Other could be a grid congestion management. That is again one of the important services which we are looking for, which helps to optimize energy flow to avoid any overloading transmission line. Going forward, for all these ancillary services, what we think, yes, we do have a regulatory framework around this, which varies by the region, and there are components around which this regulatory framework is based on, which are mainly on the basis of market design, which means all these services operate by the market, are managed by independent ISOs or a regional transmission organizations, or we can say it RTOs. There are predefined participation rules, which are mainly based on a historical or traditional generator which are dominating in the market. There are predefined pricing mechanism as well. So these are mainly a component which are already exist in a current regulatory framework. Using those framework, we can take a participate in mainly two type of energy market. One is a day-ahead market or a intraday market. So as we are talking about the current regulatory framework, there could be some challenges which we know and we will talk about later, and we will also talk about what are the possible solutions. So let's talk about the current challenges in the current regulatory framework. As we mentioned, it's based on a market design and participation. It could be one of the challenges, we can say, which means an integration of a DERs. So small scale in renewable generation and prosumer face limited mechanism for market participation. So this could be one of the challenges which is having a current regulatory framework, a pricing mechanism, which are like developing a dynamic pricing models that accurately reflect real-time grid condition in a high complex environment. A technology complexity, digitalization challenge, which are managing of large volume of data coming from sensor, IoT devices, and for that we need some sort of advanced mechanism to support that ecosystem. There are policy gaps and regulatory framework. There are policy gaps in the regulatory. There are some sort of other challenges which could be a cost recovery, balancing fair compensation for ancillary services provide while minimize consumer costs is very difficult. And last but not the least, infrastructure limitation. As we all living in a legacy system of utilities, and it's often lack the capability to support the requirement of modern ancillary service. So these are the few of the challenges. It could be a more challenge, but yeah, I have just pointed out few challenges. So as we are talking about the challenges, we definitely talk about some sort of a strategic solution which we can think about. Excuse me. One is the regulatory innovation. We should develop some standardized regulation to facilitate DER participation. That could be one of the solutions which we think of. We should also think of a market redesign, which is again one of the main challenges which are facing by the current regulatory framework. So we should implement a real-time pricing mechanism to reflect the dynamic nature of our demand and supply. Introduce the performance-based incentives for the ancillary service providers. We should also invest some of technology integration, cyber security measure, and most of the important are stakeholder collaboration, which gives our user experience in a different way. So these are the few solutions which I have mentioned over here. So what will happen if we apply all these solutions? It will definitely robust our current regulatory framework, which helps to enhance stability, ensure fair practice, safeguard consumer and investors. Some of the benefits, key benefits are here: grid reliability and resilience, economy efficiency, renewable energy integration, and consumer empowerment, which is one of the important outcome of all these benefits. So when we are talking about these benefits, there are few global practice which is already around us, which reform their regulatory, like in US, UK, and Australia, and other European countries. They use that, or they reform their regulatory framework to enable energy storage, DERs, and advanced grid services, which helps them to enhancing flexibility and stability. Few of them are in the US market, the California Independent System Operator, the PJM, which is Pennsylvania, New Jersey, Maryland, which we short it as a PJM. It's a regional RTO in the eastern United States, which helps or which provide open access to transmission and performs long-term planning. In Australia, we have AEMO. So these are the few of the global practice which are using the, or which are reforming their regularity. So having said that, I would like to conclude here. Ancillary services are the backbone of uninterrupted power supply from producer to consumer. And there are some of the key takeaways, which are increased revenue, new income opportunities, market risk and cost management, enhanced customer experience. With that, I would like to conclude. Thank you.
Thank you, Mr. Basit, for a nice presentation. Definitely ancillary services is one thing without which we can't live, and a strong regulatory framework is needed. It is still under developmental stage. Some regulations have been issued, but they are getting amended and modified over a period of time. And maybe in another year or so, probably we will be at a much better position than so. Because even I remember when the issue of fixing tariff for EV charging was being talked about. That time the concept of ancillary services was not existent. The one issue came was that the person who is putting up a charging station is he entitled to sell electricity? Because he is buying from a distribution licensee and supplying to a EV. Basically, he is selling electricity, buying from, but whether it's trading, it will come under trading. But then for trading, whether he is a licensee, there are many issues came in.
Yes, correct.
And that was the first time when this ancillary services came into existence. That this can be used as a part of service rather than using. And we framed the regulations for EV tariff. We used as a concept of a society. That in today's society building where there may be 500 or 1,000 flats, there is a common point of sale by the distribution licensee, and then it is distributed by the association or the developer, and he is charging to everybody. So we use that as a logic in back of our mind. But when we were talking to the forum of regulators, and even the Honorable Minister at that time, I think Mr. Piyush Goyal was there at that time. So then it emerged that we have to find some way out which is within the ambit of the act, and still we can do it. And then the concept of ancillary services came in. And then came on the battery storage. Then storage was another one when added, and now it's coming to so many things as an research. Even the short-term trading is also sometimes coming as ancillary services somewhere.
Yes,
so it's a really great
we
thing.
Saw yesterday V2G also.
And a unified kind of a regulatory framework for ancillary services is also a requirement. So that everyone is at the same platform.
I think.
So probably that is a requirement. Any questions from the audience, please? No questions. Probably lunch is restricting everybody to raise the question.
Okay, thank you.
So,
Thanks
thank
for
you
that.
very much.
Thank you.
Thank you. Thank you very much. Thank you, Mr. Singh, for being here and going through the presentations. Now, I would request you if you can hand over the token of appreciation to our authors.
Sure.
Yeah. I would like to invite Mr. Vikas Gupta. He's not around. Okay, we'll go to Sumangal, Bhaumik, please. Round of applause for Mr. Sumangal, Bhaumik. Thank you. Mr. Dheeraj, Gangadharan. Miss Najda. Is she around? Yeah. Thank you. Mr. Priyanshu Agrawal. Mr. Anil Kumar Ojha. He's not around. Mr. Ajit Kumar Singh. Mr. Tushar. Ms. Purnima Gupta. Big round of applause for Ms. Gupta. Ms. Maitri Karthik. Gufran. Thank you. I would like to give it to Sir.